Hello everyone, and welcome to NEAF, the virtual experience. I am Vinny Coulahan, and I'll be your MC today. I hope everyone is staying safe at home. Today we are bringing you NEAF to you, so sit back, relax, and enjoy our virtual show.
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be, and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
As a mom, welcome.
It's great to be here. Thank you. Wow, there are a lot of you. What a great conference.
Friday, I got promoted chief engineer, and that means that I'm really busy with the mission.
No one has ever seen before.
Hi everyone. It gives me great pleasure to introduce the senior editor with the Sky and Telescope magazine, Mr. J. Kelly Beatty, to NEAF, the virtual experience. Please sit back and enjoy his talk with us today. Thanks.
Hello everyone, and welcome to the NEAF 2020 virtual experience. I'm Kelly Beatty from Sky and Telescope magazine, and like you, August 21st, 2017 holds a special place in my heart. On that day, and I suspect a lot of you, stood in the moon's shadow during the Great American Solar Eclipse. And I'll bet for a bunch of you, that was the first time you had seen the sun's corona. Wasn't that amazing? We have a saying in the eclipse business that when you see a total solar eclipse for the first time, your first words are, "When's the next one?" And that's what this talk is all about. I'm going to take you through some of the upcoming solar eclipses and show you how you can once again stand in the moon's shadow. Before we get to the upcoming events, let's talk a little bit about why eclipses happen at all. Recall from your high school geometry that when two planes intersect, that intersection is a line. And when it comes to the orbits of the Earth and Moon line up with the Sun at what are called the nodes, about 6 months apart. That's shown a little bit better here. The Moon's orbit is tipped by about 5 degrees with respect to the plane of the Earth's orbit. So 6 months apart, everything has the potential to line up. If that lineup happens to occur during full moon, then we get a lunar eclipse, when all or part of the moon passes through Earth's shadow. Now, Earth's shadow has two parts. The penumbra is kind of a partial shadow. As the moon passes through that, from the moon's surface you would see part of the sun covered. In the darker core shadow, the umbra, all of the sun would appear to be covered. This sequence of photos shows a total lunar eclipse when the moon completely gets immersed inside the umbra. You know, when that happens, the moon doesn't completely disappear. A little bit of light from the Earth's atmosphere gets refracted in, giving it that red color that's so distinctive. Here's a list of upcoming lunar eclipses, and I want you to notice that there are no total lunar eclipses until May of next year. So we have a little ways to wait until then. Now, when that nodal lineup occurs at new moon, we get an eclipse of the sun, a solar eclipse, and the moon's shadow falls on the Earth's surface. Now, the moon's a lot smaller, so the actual spot from which you can see a solar eclipse is just a small fraction of the Earth's surface. And here is that spot, in this case during a total solar eclipse in 1999, as witnessed by the cosmonauts aboard the Mir space station. The moon's umbra, or shadow, is crossing Europe, which was pretty cloudy that day. Not a lot of people on the ground got a chance to see totality. And when you do get to see totality, it's a remarkable, otherworldly experience. All around you, the sky gets dark, the temperature goes down, and up in the sky there's a black bullet hole where the sun used to be. Surrounding that is the ethereal, wispy, electric white corona, the sun's atmosphere. There's lots more to see during totality than just the sun's corona. For example, just before and after totality, the last bits of sunlight are streaming through valleys on the moon, and you get a phenomenon called Bailey's beads. You see them here in this sequence of photos at upper right. Also, the chromosphere, the crimson-colored layer in the sun's lower atmosphere, comes into view, and that's dramatic as well. And you can often see prominences, eruptions of hot gas ejecting outward into space from the black lunar silhouette. Now, when the moon passes directly in front of the sun, we don't necessarily get a total solar eclipse. As you can see here, the moon's apparent size in our sky varies depending on whether it's a little closer or farther from Earth. And that distance has a lot to do with what kind of solar eclipse we see. When a solar eclipse occurs and the moon is relatively close to us, then the lunar disk is big enough in the sky to completely cover the sun's disk, and we get a total solar eclipse. On the other hand, if the moon's a little bit farther away than average, then even though it's passing directly in front of the sun, it's not big enough to completely cover the sun's disk, and what we're left with is a ring or annular solar eclipse. The entire process of the moon gradually covering the sun and then uncovering it lasts more than 3 hours, but the exciting part during totality, represented by the 3 frames there in the middle, can last no more than 7 minutes. It's really a very short period of time. Here's a map showing the paths of all total and annular solar eclipses over a 20-year period. The totals are shown in blue. The pattern looks kind of random, doesn't it? But if I take away the annulars and leave only the total paths, now a pattern does seem to emerge. For example, look down in Antarctica. There are 2 paths, one in 2003, the other 2021, that really look similar. Also, there's one in 2006 crossing Africa that looks an awful lot like the one coming up in 2024 that crosses the United States. This repeat pattern every 18 years, 11 days, and 8 hours is called a Saros cycle. Now, calculations suggest that every spot on Earth experiences a total solar eclipse about once every 375 years on average. So I asked cartographer Michael Zeiler to give me a plot of all the total eclipse paths across the United States from the year 1750 until 2125, 375 years. And you can see that there are some pretty big gaps. Okay, Let's go for 1,000 years. Here's a plot by Fred Espenak showing 1,000 years worth of total solar eclipses across the U.S., and there are still some gaps there in west central Texas, for example. Of course, we all remember the total eclipse in August of 2017, the Great American Eclipse that went coast to coast across the continental U.S. Many of you, I suspect, actually got a chance to see that. You might recall that the weather prospects for that eclipse heavily favored the western half of the country. There on the east coast, it was much more likely to be cloudy. And yet, on eclipse day, it was clear almost along the entire track. Sky and Telescope had two big groups for the 2017 eclipse. This was the group I led in Hopkinsville, Kentucky, a group of about 200 people. And then my boss, Peter Tyson, had another group of 200 people in the tiny town of Glendo, Wyoming. Both of us saw a really great spectacle that day. On average, it's about 18 months between total solar eclipses. But after 2017, the next one didn't occur for about 2 years, last July, and it was a whole lot harder to get to. You can see here that the path was across the southern Pacific Ocean and only crossed land in Chile and Argentina near the end of the path. Here's a close-up of the path as it crossed South America, very near sunset local time. The Andes were actually an issue in terms of making sure that you could see the sun. Sky and Telescope had two groups for this eclipse. One was in the little town of El Molle, shown by the asterisk there. This is a plot by meteorologist Jay Anderson that shows the statistical likelihood that there would be clouds during the time of the eclipse, with blue being good and red bad. And you can see that the prospects for clear skies were actually really good during this eclipse last July. This is the Sky and Telescope viewing site at Casamoye, a resort in the Elqui Valley of Chile. It was a very nice place, and we all had a terrific view of the eclipse. Here's a group photo that we took before the eclipse got underway. You can see a lot of smiling faces because the skies were beautifully clear that day. And in fact, as we looked over in the west, you can see the progression of the eclipse across the sky, culminating in totality with this beautiful setting of the Andes around it. Now, I'm not much of a photographer, but here's my shot of the corona during totality, and it's instructive. The sun's poles are upper left and lower right, and you can see the delicate brushes of the corona extending out into space. Along the equator, at upper right and lower left, the corona is broader and extends farther out. This is what we call a classic solar minimum corona, the shape that we get as now at solar minimum. At solar maximum, the corona tends to be more uniform all the way around. Now, just before totality began, I turned around, and on the geodesic dome behind me were these beautiful shadow bands, the horizontal stripes that you see there. This is something that is very difficult to see during an eclipse, and I've never seen them this prominent. Here's a short video that shows what they looked like just as totality was beginning. Now, the other Sky and Telescope group was nowhere near us. They were aboard this LATAM Airlines A320 aircraft out over the Pacific. This map shows the situation. Here, the moon's umbra is represented by a series of overlapping gray ellipses. Now, as the moon shadow approached the coast of Chile, it was possible to position a plane out over the ocean and have it literally fly through the umbra, shown here by the yellow lines. And that's exactly what this plane did. Our group and the flight crew posed for a snapshot just before getting on board the plane in Santiago and departing for the eclipse. From altitude, you get an entirely different perspective on totality. Yes, you are looking through the plane's windows, and you can see some secondary reflections there, but you also get to see the entire event play out beneath you. You can see at the bottom there, the shadow of the moon is literally crossing the clouds below the plane. These folks look really happy, and why not? They've just seen totality from 37,000 feet. In the back there, standing up, is Camille Carlisle from the Sky and Telescope staff. You notice there aren't many people here. That's because we can only observe totality from one side of the plane, so we spread everyone out from front to back and only had 2 people per row. Okay, those are all in the past. What about looking forward? The next big solar eclipse will happen in June, just a couple of months from now, when an annular solar eclipse will be visible starting in Africa, crossing the southern half of the Saudi Peninsula, then across southern Asia, India and China, before ending up in the Philippine Sea. Now you can't see the corona during an annular solar eclipse because the moon's disk isn't quite big enough to completely cover the sun. But annulars have a beauty and a starkness all their own, as you can see here. For example, just before and after the midpoint of the eclipse, you can see Baily's beads for an extended period of time along the lunar limb. And it offers you an opportunity to see an enhanced view of the chromosphere too, if you time it just right. The paths of total and annular solar eclipses are quite narrow, only about 100 miles wide, but thousands of miles long. So consequently, the prospects for clear skies along the eclipse path can vary tremendously. During the annular eclipse coming up in June, for example, weather prospects are great over the Saudi Peninsula and Oman near the beginning, and very, very poor over China and Taiwan near the end. Unfortunately, the ongoing pandemic means that a lot of the people who had planned to see this eclipse won't get a chance to. So let's look ahead to the next total solar eclipse, which will occur in December of 2020. And as luck would have it, it will again cross Chile and Argentina in South America. But instead of occurring near sunset local time, this time the sun will be high overhead during the middle of the southern hemisphere summer. As this plot by Jay Anderson shows, the weather prospects in mid-December across Chile and Argentina are actually quite good, and anyone traveling to South America in the hopes of seeing totality will likely have clear skies. Sky and Telescope is going to have a group in western Argentina up against the Andes in the Patagonia region. We're going to be based in the little town of San Martin de los Andes, very pretty and picturesque. We're going to head out to a site along the center line where we have our fingers crossed for clear skies that day. Now, another good way to see totality is aboard a cruise ship. For December 2020, here's the route of a ship that's going to leave Santiago, putter along the Tierra del Fuego region of South America, dance along the Antarctic Peninsula, and then come up and see the total solar eclipse just off the east coast of Argentina. That particular route involves a ship from Holland America, seen here with the dramatic Antarctic Peninsula in the background. You know, ships like this offer a certain amount of mobility. If the weather is dicey on eclipse day, you can always sail to a spot along the path where the skies are clear. Roughly 6 months later, there'll be another solar eclipse, this time an annular, that will be observable from southern and eastern Canada. Now, as you see in the plot here, the track is truncated just north of Minnesota. That means that from that location, looking to the northeast, you'll see the annular eclipse right at sunrise. Unfortunately, as this plot from Jay Anderson shows, the chance of cloudiness along the eclipse track is very high, except maybe in northwest Greenland. Another thing too is that this is really remote territory. I don't know of very many people at all who are going to attempt to see this eclipse. And the same goes for the total solar eclipse that follows on December 4th, 2021. You can see that the track is seriously far south, over Antarctica and the Southern Ocean. This is not exactly the kind of place that you plan to go on vacation. And as you can see by all the orange in this plot, the weather prospects are really not good, except maybe over parts of Antarctica along the track. And again, getting into the path of this eclipse is going to be really challenging. Now, there are a couple of tour companies that are planning to take a few people down to Antarctica. Again, it's a really challenging trip, and the cost will be about $30,000 to $40,000 per person. Or you can take a cruise ship. And although the weather prospects are bad, there are a couple of cruises like this one from Hertegruten, which is planning to both show you the eclipse and let you set foot in Antarctica. Again, the cost is quite high, $15,000 to $20,000 per person. And finally, it is possible to take a plane to see this eclipse. I know of at least 2 companies, Sky and Telescope being one of them. They are trying to get planes into the path of totality. Again, it's a little challenging because the flights have to leave from the southern tip of South America, and the planes have to get into the path of totality near the time of sunrise. So stay tuned to Sky and Telescope for more about this particular possibility. Looking a little further ahead, there will be a hybrid solar eclipse in April of 2023. This is kind of a quirky geometric oddity. At the beginning and ends of the track, you'd see an annular solar eclipse, but in the middle, at the point where Earth is a little closer to the moon, and therefore the moon looks bigger, the eclipse becomes total. And as you can see from Jay Anderson's cloudiness predictions here, the prospects are actually quite good in the sea between Australia and Indonesia, where it will be total. Later in 2023, there'll be an annular solar eclipse that will be widely seen throughout the western U.S. You can see here the path goes from Oregon down through the Rockies and through Texas. And the weather prospects are actually very good for that. And then, of course, in 2024, there'll be another total solar eclipse crossing the United States, the second one in 7 years. This time, the path will come up through Mexico, across through Texas, the Midwest, and then ending up in the New England area. The next 3 maps show the path of the eclipse in a little bit greater detail. The greatest duration of totality will take place in central Mexico, but very quickly the path moves up into Texas, clipping San Antonio and Austin, and also Dallas and Fort Worth before moving to the northeast. As it makes its way across the U.S., the 2024 path just misses St. Louis but goes right over Indianapolis, Cleveland, and Buffalo before heading into New England. And then finally, the path crosses northern New York State, northernmost Vermont and New Hampshire, and north central Maine. Now, I have to remind you that it's going to be April, and so the weather prospects are a little iffy for this time of year. In fact, here's the weather map from Jay Anderson, and you can see that the farther south and west you go along the track, the better your prospects. Up here in New England and the Northeast, it's not so good. Here's another way to look at the weather prospects. In this map, it's color-coded according to which month is the cloudiest. And so the eclipse takes place in April, so key in on the lime green colors. There is a patch in south central Texas, which is a little worrisome, and also in New England, there's a lot of green there. You know, it's April in New England. It could be snowing on the day of the eclipse. Now you might say to yourself, wow, 2024 seems like such a long ways off. But in fact, plenty of companies are already lining up tours for that 2024 eclipse, and many of the other ones that I've mentioned here. Sky and Telescope is certainly in that category, and I encourage you to go to our website, skyandtelescope.org, and click on the Tours button for more information. I hope you enjoyed that tour of upcoming solar eclipses, and I hope you get to see several of them yourself. Now, there was a lot of information there, so I've got something here that I think can help you keep it all sorted out. Sky and Telescope has a new product. It's a globe of the Earth on which we have plotted total and hybrid solar eclipses through the end of this century. This globe shows the paths of 75 total and hybrid solar eclipses through the year 2100. It's been 4 years in the making, a collaboration between Sky and Telescope and master cartographer Michael Zeiler, a dedicated eclipse chaser. Each path shows the date of the eclipse, the maximum duration of totality, and where the eclipse will be greatest. So, armed with my presentation and maybe this globe, you're ready to start planning your next eclipse expedition. I hope to see you on one of those trips.
everybody, Scott Roberts and
Mike Hatch
here at the Explore Scientific showroom for NEAF, the virtual experience. And we're here to talk a little bit about our 16-inch truss tube Dobsonian.
Oh yeah.
Which is what? It's going to be the
door prize.
The door prize.
The door prize.
Right. And so this is an ultra portable, easy to assemble telescope, valued at what's the normal value on this?
Normal value is $31.99.
And we're gonna be giving a NEAF special on this for $24.99, but you might win it here at this event. I mentioned that this telescope is really easy to assemble. We have a little video here just to kind of show the major assembly of this telescope. When it's all assembled though, the thing that's really cool about it is that it pretty much stays collimated. But the collimation of it's pretty easy to do. And what do you use, Mike?
Yeah, so with the Dobsonian comes with the collimation tool, and it is an easy one-person collimation job. Literally, you can take this tool down there, collimate your primary mirror.
Right.
And you've got some adjustments for your secondary mirror, but other than that, you'll be ready to go.
It's all no tool knobs and stuff. Now,
is.
on normal Dobsonians, you're going to be back here making adjustments to the mirror. You might have somebody over here saying, is the laser lined up, or if you're doing a visual collimation, checking it and adjusting it. But this can be done with one person.
Right.
And that's really unique to this design. So this is a part of a family of telescopes that runs from a 20-inch telescope all the way down to a 10-inch. So we've got 4 models, all available from Explore Scientific and from our dealers here that we'll be highlighting for the NEAF special.
Right.
Anyways, guys, we have a lot more to show you. We're real excited to be here participating in NEAF, the virtual experience, and stay tuned for more.
Ready for a new kind of telescope experience? Unlock the power of your smartphone to help you navigate the night sky. Introducing StarSense Explorer by Celestron. It's fast, easy, and accurate. In minutes, you're ready to take a guided tour of the universe. First, dock your smartphone and launch the StarSense Explorer app. Unlike other astronomy apps, StarSense Explorer aligns precisely with your telescope and uses sky recognition technology to pinpoint its exact position in the night sky. Follow the simple instructions, and in seconds, the app generates a list of all the best objects currently visible in the night sky. Select an object from the list and follow the on-screen arrows to the desired object. As you move the telescope, StarSense Explorer recalibrates its position in real time. The bullseye turns green when your object is ready to view in the eyepiece. It's that simple. StarSense Explorer works anywhere in the world, no cell signal required. So whether you're in your backyard or a remote dark sky location, the universe is yours to explore.
From the time it took Voyager to leave the Earth and reach the edge of the solar system, I went from being a baby to a high schooler to a university graduate to a worker to a business owner, and now I'm a husband, a father, a postgrad student, a science communicator, a musician, a YouTuber, and a backyard astronomer. I've been lucky to reach this point to be able to buy some of the best equipment an amateur astronomer could dream of. But there's one thing I can't afford, and that's time. Astronomy has made me a more patient person, and the constant drive to get better and collect more data to capture the wonder of the cosmos is something I have to balance with everything else in my life. So when I see a telescope with a lower F number, I know that its value to me is far greater than money alone. A telescope's value is not just the sum of its parts. It comes from how much you can get it outside, and how much you can get out of it. That's why I jumped to buy the Celestron RO Ackermann Schmidt Astrograph 11. Its 620mm focal length at f2 allows me to capture the incredible southern hemisphere nebulae, sometimes within a single night, but always with revealing depth and signal. I've been shooting the universe with the RASA 11 for years now, and it's allowed me not only the satisfaction of sharing these unique views from my end of the world, but also to detect and track asteroids, which is an area I'd love to explore further. The RASA 11 easily crosses that divide between a consumer scope and a scientific research-grade observational telescope for discovery and analysis. The real limit for the RASA 11 is really how far I'm willing to take it, and it's nice to have a telescope that I won't outgrow for a long time, because time is the only thing we don't get more of.
QHY-CCD is proud to present its new line of scientific CMOS cameras with particular emphasis on two new models designed for the amateur market, the QHY-268C and the QHY-600. The QHY-268C promises to be a game changer for single-shot color imaging. The QHY-268C uses a Sony IMX571 APS-C format CMOS sensor. The IMX571 sensor is a back-illuminated 26 megapixel APS-C format CMOS sensor with 16-bit A to D, 3.76 micron pixels, and a full well capacity of 50,000 electrons. APS-C format has a large 28 millimeter diagonal measurement, about 2/3 the size of a full-frame 35 millimeter format. With read noise as low as 1 electron and 0 amplifier glow, the QHY-268C can achieve a signal-to-noise ratio greater than 3:1 with a signal of only 4 to 6 photons. This is ideal when conditions are photon limited, making this large area sensor excellent for deep sky imaging, sky surveys, and time domain astronomy. 16-bit A to D provides high sampling resolution with no sample error noise and extremely low read noise. Full-frame 26 megapixel 16-bit images can be captured at 6 frames a second, with video rates available for selected regions of interest. A 2 gigabyte DDR3 image buffer is built in. The back-illuminated sensor provides not only twice the sensitivity as a front-illuminated sensor, but greater full well and dynamic range as well. Two-stage cooling assures extremely low dark current. Based on the performance of similar sensors from Sony with 3.76 micron pixels, we estimate the dark current will be less than 1/100th of an electron at typical operating temperatures. The retail price of the QHY-268C camera is $23.99. The QHY-600 uses the new Sony IMX455 full-frame 35mm format CMOS sensor available in monochrome or color. The IMX455 is a back-illuminated 61 megapixel sensor with read noise as low as 1 electron and nearly 90% QE. The IMX455 has 3.76 micron pixels, 16-bit A to D, and extremely low dark current. The QHY-600 has a full well capacity greater than 51,000 electrons. In extended mode, the full well capacity is greater than 80,000 electrons unbinned, greater than 320,000 electrons binned 2 by 2, and greater than 720,000 electrons binned 3 by 3. The QHY600 is capable of only 1 electron of read noise at high gain, and up to 4 full 60 megapixel frames per second. Peak QE is close to 90%, and dark current is only 0.003 of an electron per pixel per second at minus 20 degrees C. The QHY600 is available in 2 versions. The photographic model uses a USB 3.0 interface and can deliver 2.5 full frames per second at 16 bits, or 4 full frames per second at 8 bits. The professional model has USB 3 plus 2 10 gigabyte optical fiber ports. It can deliver 4 full frames per second, 16 bits, or 10 frames per second, 14 bits, and can also produce 30 frames a second at 8K video. It has a programmable trigger port in or out, and a customizable field programmable gate array for custom programs. An early bird version of the QHY600 is available for $5,000.
For millennia, man has looked to the stars and wondered what else is out there. And after 400 years of astronomical innovation, we have the ability to see deeper into the universe than ever before. We have discovered countless galaxies and billions of stars, and now even planets orbiting those stars. But due to the limits of current technology, those stars are preventing us from directly viewing those worlds. Exoplanets, no longer the stuff of science fiction. In recent times, the hunt for these elusive objects has become one of humankind's most focused projects. The search for exoplanets is not only key to furthering scientific knowledge, but possibly our survival as a species. But there is a problem. The search for exoplanets has been difficult. Deep space objects can be hard to photograph for numerous reasons. In the case of exoplanets, the main culprit is light. With exoplanets orbiting stars massively larger than our Sun, the light given off can be incredibly blinding. This overpowering glare can make exoplanets and other deep space objects literally impossible to see. Until now. Introducing the Digital Occulting Device by Digital Optica. This revolutionary new device can dim bright objects in space, allowing for unprecedented imaging. This breakthrough technology will aid in the discovery and direct imaging of exoplanets and other deep space objects that, until now, were invisible to our imaging technology. The Digital Occulting Device, paired with a new proprietary control software, gives researchers the ability to block out the glare of planet-hosting stars, allowing direct imaging of extrasolar planets. The device and software can take live images and block out selected objects, all while simultaneously recording the image data. This revolutionary process is capable of pinpoint accuracy and exacting light dimming without any of the limitations inherent in the current technologies in use today. What typically takes months of observation and countless hours of data analysis can be accomplished in hours, even minutes, with this new technology. The Digital Occulting Device will change the way we see our universe and perhaps answer the age-old question, are we alone? While exoplanet research is at the forefront of focus, this technology allows the possibility of views deeper into the past than ever before. Objects in deep space once masked by glare can now be visible. Distant galaxies, black holes, even looking back to the Big Bang closer than ever before. The Digital Occulting Device has been purposefully designed to be scaled up or down, so it can be made available to every level of researcher. From the backyard astronomer to large land-based telescopes, all the way up to space-based platforms such as the James Webb Space Telescope and any future telescope design. Innovation is a must if we are to ever understand the universe and our part in it. Digital Optica has put that innovation in your hands today. What will you discover? The future of deep space photometry is here with Digital Optica's revolutionary digital occulting device. Digital Optica, the future of seeing.
Hey everybody, Scott Roberts here from Explore Scientific. And today I'm going to be talking about our AR Airspace Doublet Series telescopes. We have a 4-inch, a 5-inch, and a 6-inch telescope. All three of these telescopes come with an 8x50 finder. They have a 2-inch mirror diagonal. They've come with our famous handle with the slotted grip here that allows you to use it like a piggyback bracket for attaching guide scopes or other pieces of equipment. The telescopes also are completely multi-coated. They have 3-point push-pull collimation screws, so you can get a precision collimation with them. But it is a refractor, so these things do hold their collimation really well. These telescopes are very special because they are normally telescopes in this class do not have this nice of accessories. They don't have 2-speed focusers on it. These do. The hardware on it is really rugged. These telescopes were intended for educational outreach purposes, okay? And in fact, the 5-inch telescope was chosen by UNESCO for their space education program, where they've taken these telescopes to third world countries to teach students how to become scientifically more literate. And I'm proud to say that we've been a great part of that. So that's been really awesome. The telescopes are also used in astrophotography. If you look at astrobin.com and search for Explore Scientific AR152, you're going to see some incredible narrowband images done with these with the AR152 telescope. I was really stunned myself because it looked like, gosh, it looked like an image done with one of our ED telescopes. So I was really surprised. All three telescopes sell for under $1,000 normally. But during this special time for NEAF, the virtual experience, we have a special running where you can buy them for even less. So visit us and visit our dealers and get that special deal. More to come.
Hi folks, I'm Kelly Beatty, and after a long northeast winter and spending way too much time indoors, I'm eager to get outside with one of my scopes and just enjoy views of the night sky. Summer is coming, and that's the time for the big star parties. You know, the ones where you pitch a tent for the weekend, get all your food from a canteen truck, and deal with those awful porta potties just to get decent views of the stars. But it doesn't have to be that way. Let me tell you about a completely different, all-inclusive stargazing experience. It's called MARS, the Maine Astronomy Retreat and Symposium. MARS is a week-long gathering of people who really love the night sky. This year it occurs during new moon, August 16th to 22nd, when the summer Milky Way will be blazing overhead at sunset. It's held at the Madomic Retreat Center near the small town of Washington, Maine. Madomic is just a few hours north of Boston, and from there it's an easy drive to some of Maine's best sightseeing destinations. But what really sets Madomic apart is the darkness. Central and northern Maine are famous for having some of the darkest skies on the East Coast, and as this map shows, Madomic sits in the middle of a big zone that's almost completely free of light pollution. The skies there are routinely better than 6th magnitude, with stars all the way to the horizon. Owners George and Holly Stone, along with David Bruner, have maintained Madomic for decades, and they're amateur astronomers with a passion for the night sky. For example, Years ago, they switched to red lighting outside all the cabins, and they could have stopped there, but they didn't. Here's a view of the observing field, which is atop a hill with great views in all directions. You can set up either on packed gravel or on nicely trimmed grass, and there's plenty of power available for all your gear. And that building on the left, we call it the Pavilion. It offers a place to take a break with snacks and hot and cold drinks available all night long. There's a fridge, real toilets, and lots of room to store your gear if the weather threatens. Whether you're into visual observing or astrophotography, there's plenty of room to spread out on the observing field. That's because the attendance at Mars is strictly limited to just 50 people. And it's very secure. When you're ready to call it a night, you can feel confident just covering your optics and taking the short walk back to your cabin. Most of the cabins are set up as duplexes, like this one, and each side accommodates 2 adults. But don't let the word cabin fool you. Of course, they're rustic, as you'd expect, but they're much more than just a roof over your head. Inside, you'll find beds, real beds, with sheets, pillows, wool blankets, and towels provided, and full private bathrooms with showers as well. The cabins feature red lights on the outside, and inside too if you wish, so you can observe for a while, then come indoors for a little snooze, and then head back to the observing field without ever losing your dark adaptation. During the day, we meet in the big dining hall for family-style meals. Each day, an on-site chef and kitchen staff prepare a delicious breakfast, lunch, and dinner. Did I mention that all the meals are delicious? And there's plenty of variety, too, with great options for vegetarians. At one dinner, you can feast on lobster and steamed mussels. Did you know that lobsters are the official crustacean of the state of Maine? Go figure. The symposium part of Mars takes place next door, where, throughout the week, you'll hear a great assortment of talks. Here's a shot of astronomer Don Pettit describing his experiences on the International Space Station to our group in 2018. This year, you'll hear presentations by 4 well-known speakers. I'll be there, of course, and I usually talk about interesting aspects of space science like killer asteroids or why Pluto got demoted. I'll be joined by my longtime colleague Bruce Berger, who serves as our telescope and hardware guru. Bruce is a former president of the Amateur Telescope Makers of Boston and now serves as director of the club's Research and Imaging Observatory, or ARIO. This year's keynote speaker is Dr. Sarah Seeger, an incredibly accomplished professor of physics and planetary science at MIT. She's devoted herself to finding and studying planets around other stars, and she's deeply involved in NASA's TESS mission, the Transiting Exoplanet Survey Satellite. Sarah will be joined by her husband, Charles Darrow, a former president of the Royal Astronomical Society of Canada. Rounding out our team is Ed Ting, known far and wide not only for his insightful reviews of telescopes, but also as an accomplished deep sky photographer and speaker. He'll be there to help you get the most out of your imaging efforts. Now, the talks are great, but Madamic offers so much more. During the day, you'll have access to a private waterfront on Washington Pond. You can hop in a canoe or kayak, or take a swim in the lake's warm water. Or maybe, after a long night of observing, you'll just kick back on the shore and take a little nap. Sunsets on the lake are gorgeous. From your cabin, you'll hear the haunting calls of loons settling in for the night. And as evening twilight deepens, the brilliant blue of daylight is soon overrun by the glories of a deeply dark night sky. It'll be time once again to lose yourself among the stars. Renowned National Geographic photographer Babak Tafreshi took this nightscape overlooking Washington Pond. Mars really does have it all. A week of observing in a remote yet comfortable setting, optimized for a few dozen people who love the night sky. Many of the folks you see pictured here have come back year after year because it's the kind of stargazing experience that's hard to beat. As we like to say, it's a vacation for you and your telescope. One last thing. This year's gathering is filling fast, so head to astronomyretreat.com for more details. Thanks so much for watching, and this summer I hope to welcome you to Mars.
Hello everyone, you're watching NEAF, the virtual experience on NEAF TV.
Go.
Welcome to the online demonstration of CO2 snow cleaning. CO2 snow cleaning is a unique surface cleaning process. The key points: partial removal, from visible to 3 to 5 nanometers as proven by AFM. The key is combining aerodynamic drag force for larger particles and momentum transfer for smaller particles. This is discussed on the FAQ page about cleaning mechanisms. Second key point, hydrocarbon removal occurs, similar to solvent. It's a solvency. Third, it's a quick cleaning process with no chemical waste. The fourth, and quite important, it's non-destructive. It only has the ability to remove physically absorbed contamination. Anything that's ionic, covalent, metallically bonded stays. Even chem-absorbed particles stay. This implies that thin films properly deposited on any substrate will remain. Applications are vast. They're discussed on the website. Key ones are substrate cleaning, cleaning optics, telescope mirrors, analytical samples, AFM, XPS, art, and the equipment. Basically, the key point is the Venturi nozzle. It's asymmetric and allows for operation with CO2 gas or CO2 liquid. Handgun controls are on. Other variations, electro-polished valve, solenoid for semi-automatic operation. And then we have these astronomy units for large telescope mirrors. Different nozzle, long tube, and we have versions which can clean 2 inches and 4 inches at exit and expands further. Demonstrations for precision cleaning demonstration. It's on the website below this demonstration video under examples. And then for the astronomy units, a quick demonstration is like this for cleaning a telescope. So thank you very much, and please look at our website.
It is my pleasure to introduce to you Mr. Yuyama. Mr. Yuyama is the Chief Optical Designer at the Takahashi Factory in Yuri, Japan.
高橋製作所で工学設計を担当しております湯山と申します。高橋製作所、私30年来工学設計を担当しておりますけれども、工学設計のモットーとしましては、まずオリジナル独自の工学設計であるということ、他者の真似をしないということ、まずそれを積極的に、自分のモットーとしてやっております。で、これからもですね、新しいもの、全く世界に類を見ないもの、そういった工学設計を心がけて、皆さんに面白いと思ってもらうもの、 そういった光学設計の新製品を出していきたいなと思っております。今回FC100DZ、それを出しましたけれども、フローライトレンズ、それの可能性っていうのはまだまだありますので、対物レンズだけではなくてレデューサーだとかそういったものにもフローライト、それを使っていって、まだまだ面白いものが、APS 級の発展系みたいなもの、あるいは反射系でも、イプシロンの新製品みたいなものも出したいと思いますし、ミューロン系の加速連系ですけれども、そちらの方も、まだまだ世界に類を見ないもの、そういった設計を考えておりますので、これからも期待をしていただきたいと思っております。
Hi everybody, this is the NPay Precision Astro Engineering video short for the NEAF virtual event that's happening this weekend. Thank you so much guys for putting this together at very short notice. We do very much appreciate it. So our flagship product is the 6-position rotating eyepiece turret. You can fit 6 eyepieces or other accessories onto it, and then it sits on the back of your telescope and rotates around like this, so you can see what you want to see in different magnifications. All the eyepiece sockets are parfocal, so everything stays in the same focal plane. And we recommend this for telescopes at refractors at 4 inches or above, or Cassegrains at 8 inches or above. Our other main product is the Thea 90 collimating star diagonal, which is the world's only star diagonal with a built-in filter changer, which fits at the front also magnetically. The backplate is tip and tilt adjustment. There are 4 screws to effect that, so you can collimate the unit once it's on your telescope. The front nose unscrews like so. So if you desire, you can attach the unit to either your focuser or your telescope. And the nose itself is threaded inside, so you can double up on your filter combinations. Our other product is the Thea Astro Imaging Filter Changer. This has been endorsed by Damien Peach, and you can read all about it on our website. It's an inline magnetic filter holder, so it has a very small amount of back focus. Because it's magnetic, your filters are held in exactly the same position throughout the exposure. As the telescope moves around or moves upside down, for example, if you meridian flip, then the filter will stay in exactly the same position. Thank you so much for watching our video. You can find out full details of all our products on our website. The link is below this video. Thank you again to the guys at NEAF for arranging the virtual event, and I really look forward to meeting you in person in September. Thank you.
Hi everyone, Dan Higgins at Camera Concepts in Stony Brook, New York, and thank you so much yet again for joining us for NEAF, the virtual experience. And I got our next set of deal for you. We got the AZGTI Deluxe version. This is a Camera Concepts exclusive. Let's take a look at what we did here. With some minor additions, we were able to take the AZGTI and make it a fully functional equatorial mount capable of astrophotography. So let's talk about payload capacity. Payload capacity on this is 11 pounds, so it's really good for DSLR with a decent sized lens, small refractors, really good for grab and go, really good for vacation. This is what I use it for. This is actually mine, so it doesn't come with the Velcro. but you know, it's really good for grab and go and setup, and you know, something really quick and easy. It's got a V-style dovetail saddle up top. Comes with your shaft, your counterweight, the wedge, the pier, and also the tripod legs. $475, all inclusive. So built-in Wi-Fi, you can control your mount from your phone, tablet, iOS or Android device. Fully assembled, it's less than 10 pounds. It's nothing. It's nothing. It's awesome. And again, wide field, small refractors, awesome deal, great vacation package, $475. Come on down to cameraconcepts.com or give us a call at the store, 631-475-1118. Or if you haven't seen it, you can go on our website and get a lot more information on the website about that. I did a video on the software and the hardware with my buddy Minos. And it's also on youtube.com at Astroworld TV. So again, go to cameraconcepts.com, place your order for the AZ GTI Deluxe version, $475, and your next vacation will be awesome. Talk to you soon, and thank you for watching. Hi everyone, Dan Higgins again at Camera Concepts, and thank you again for watching us at NEAF, the virtual experience. So we got some more telescopes for you. We got Skywatcher and the return of the Dope Doublet discount. It's awesome. They do it every year for the past couple of years, and it's awesome. So starting off with the Evo guide, and for those of you that are astrophotographers out there, this little 50mm Evo guide is awesome. So come down and get it. Normally $275, you save $50. It's now $225. Then you go anywhere from the 72 ED to the 150 DX, and you can save anywhere from $50 to $250 on almost the 150s, almost 6 inches of scope. That's humongous. So normally the 150 DX is $3,200. You're now getting it at $2,950. You want something with a wider field of view? Get the 80. You got the 80 ED. Normally $825, now $765. You save $60. So you got the Dope Doublet discount. Here's a list of the prices on the screen. And if you want, you can always come to our website at cameraconcepts.com or check us out on the phone over here. It's 631-475-1118. So thank you so much for watching us at NEAF, the virtual experience. Don't forget the Dope Doublet discount from Skywatcher. And come to cameraconcepts.com and check it out. Thank you for watching.
Oh, buongiorno! I'm so happy that you are here. Welcome in Italy. Usually in this part of the year, I come to US and we talk together about your telescopes and how to improve your astrophotography. This year, you came to my house, so I want to show you how I use my telescope with all the Prima Luce Lab devices to make the best astrophotography. I have a Celestron telescope on a Skywatcher mount. And you know, Italy is really smaller than the US, and here portability is a very important factor. Cars are a lot smaller than yours, and since we often move in search for low light pollution, I have to have a telescope that may fit even on a 500 car. One of the key factors for a successful imaging is focus, and that's why we developed our Esatto, our high load capacity microfocuser that I use on my Edge HD telescope to let me control the focus and refocus during acquisition with the primary mirror locked. This way, avoiding any image shift and without the use of the internal focuser. The Esatto is a complete motorized focuser with a very high load capacity and incredible resolution of 0.04 microns per step, USB connection and even Wi-Fi control. It also comes with a virtual handpad, so you can control it from your smartphone, even without a computer if you like. But if you already have a good quality focuser, like the ones commonly found on refractors, you can install our Sesto Senso focusing motor and have the same advanced feature of the Esatto on your focuser. Oh, come on, give me back my Esatto. Take a look at this great Borg astrograph with a larger Esatto 3 inches. I said, give me back my telescope. And you know what? Many years ago, we understood that all the technology that are mostly related to astrophotography had a critical aspect. You were expected to control all of this with the same computer you were using to work, study, surf the web, or read emails. And it was strange, since the control computer is the brain of the entire telescope, and it was the only not specialized part of it. So we decided to create the first computer specifically designed for astrophotography, the Eagle. The Eagle is a powerful Windows computer that replaces a standard laptop. You can install it on your telescope thanks to the special Plus case. The Eagle allows you to remotely control and power all the devices that you can use in astrophotography without any limitation because it runs Windows. So, instead of installing your preferred device and astrophotography softwares on your laptop and trying to figure out how to connect all the devices with long cables, you have your computer on the telescope and you connect everything to it with very short cables. And you can still use your preferred astrophotography softwares. The Eagle works like a router. It creates its own Wi-Fi network, so you can connect to the Eagle Wi-Fi any other computer, tablet, or even a smartphone. And you can remotely see what's going on in the Eagle, start your software, control your devices, and enjoy more your astrophotography. And the Eagle is much more than a computer. In fact, it comes with 4 12-volt power out ports to power camera mount, focuser, filter wheel, or other accessories, and 3 dew heater ports that allows you to control power of the dew heaters without the need of an external controller. This way, you can power all your devices through the Eagle, reducing the number and length of cables. And you will have only one power-in cable that can go either to a 12-volt battery or an AC adapter, while all the rest of the cables are on the telescope. This way, when the telescope moves, all the cables, both power and data, move together with it. And this fixes all the problems related to cable management. Well, that's all for now, my friends. And I hope you enjoyed my presentation here from Italy. See you soon at the next NEAF. Clear skies!
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
take you on a journey to the outer reaches of the solar system.
Mission Operations Manager. As a mom, welcome.
It's great to be here. Thank you. Wow, there are a lot of people. What a great conference.
Friday, I go from chief engineer, and that means that I'm really busy with the mission.
No one has ever seen before.
Welcome back to NEAF, the virtual experience. Our next speaker, Jenny Radenbaugh, is a planetary scientist and is a science team member for the newly selected Dragonfly rotorcraft lander mission to Saturn's moon Titan. This newly selected billion-dollar project is going to take us deeper into Saturn's moon and open up a whole new vista of learnings for us. Please welcome Jenny Radenbaugh to NEAF, the virtual experience.
Hi, everybody. This is Janie Radenbaugh. I am so excited to be with you today and to be talking to you. I wish I were there with you in person, but one day we'll have a big party and I will be so excited to meet you. But I want to talk to you today about a couple of really exciting things. Mostly I'm going to talk to you about something I'm involved in that just happened this past year, and that is the very exciting Dragonfly mission to Saturn's moon Titan. This is the next New Frontiers mission in NASA's quiver. It was just chosen last July, and I am on the mission team, and I am so, so excited about that. I'm gonna make this a little bigger so you can see me better. Okay. It is really spectacular, really fascinating, and I have so much to tell you about concerning that. But first, I actually want to talk about something else that I've been able to do. And the reason I'm thinking about this a lot is just because of the very interesting times that we live in now. And I'm thinking about how I cope on a daily basis with these very significant changes in ways that draw on the skills I learned going down to the bottom of the world to search for meteorites. I must really like this because I've been 4 times and I'm not done yet. I really want to go back, and it's one of the most spectacular experiences I've ever had in my life. It's a chance to go and pick up pieces from outer space that are just sitting out there on the ice. You just drive a snowmobile right up to them and pick them up and put them in a bag and send them off to NASA. And we just, every time we see one, we just are delighted and just kind of can't believe it. But we end up finding hundreds every season. And the reason why is a subject for a different talk. But I do just want to mention that there's a lot of time spent waiting when we're doing this. We wait to get ourselves to New Zealand. We wait to go from New Zealand to McMurdo Station, which is the main US base in Antarctica. And then even when we get to McMurdo, we wait to get out into the field. And sometimes we wait for weeks. Sometimes it's a month that we wait in McMurdo before we can get out into the field. And it's frustrating, but at the same time, I pinch myself and I try to remember that I'm in Antarctica, and that's a real just benefit to doing this entire thing. And so I spend time going around and walking up to the tops of mountains, and here is Manavie looking out over McMurdo Sound. And this is the view that many of the early explorers had during the heroic age, the early 1900s. And here's a cross erected as a memorial to those explorers. And so sometimes we really feel like they did, although our waiting is nothing compared to what theirs was like. I believe this is Shackleton's expedition and the tremendous amount of waiting they had to do on that trip. But we still find things to entertain ourselves when we're out there. You know, I ride a fat tire bike out to the runway, and I probably never would do that in normal circumstances, but I had the time, and so I took advantage of that opportunity. And then once we get out into the field, we're still waiting. We're waiting to kind of get things unloaded. We're waiting to get it set up. Do we have all of our ski-doos? Do we have all of our field party members? Sometimes we're waiting in the field until they come. But we're so grateful to be there, and it's so beautiful. We spend up to 6 weeks in the field in tents, and go out every day on snowmobiles and look for meteorites. Even when we're searching, there's a certain amount of waiting. You just look at our attitude here. We're just kind of hanging out. We're just waiting. I love this one right here of Manavish is just reclining, and you think, oh, that looks pretty nice. But if you look down near the bottom of the skis, you can see a lot of snow blowing. And this is starting at 0 degrees, and then the wind blows. And so it is 0 Fahrenheit. So it is always cold there. And we get used to it. We know that that's what it's going to be like when we're out. And then there are the days that we spend in the tents, and it's up to 1/3 of the time that we have in the field, we're in the tent and we're waiting for the weather. When the wind blows, it's picking snow up everywhere. We're huddled around an anemometer to see just how fast the wind is blowing here. And then we can calculate the wind chill. But of course we can't go out and search during these times. So we just sit and we wait in the tent. And while we do, we cook some beautiful stews, and we write in our notebooks, and we do little craft projects. And I kind of dive into those recesses of my brain that I don't normally get to access. And that is a real privilege. And I'm trying to remember that right now. I'm trying to remember that I can take some time to do things that I wouldn't normally, and I hope I'm taking advantage of that. We should remember that the Apollo astronauts also did a certain amount of quarantining. You know, they had these spectacular days in the field, up to 3 days on the moon. And then when they came back, they couldn't, run to the arms of their loved ones or go out and talk about everything to the public. They had to sit in quarantine for 2 weeks because we didn't know what to expect out there in space. And so they complied with that, and just like they did with everything else, and learned how to wait themselves. So in many ways, I feel right now like Luke Skywalker. Always comparing my life to Luke Skywalker. I feel like, gosh, I'm just sitting there. I really want to go out somewhere to those remote corners of the galaxy and explore and do those remarkable things. But I need to be home for a while, just like all the rest of us. And so I'm trying to make the most of it. But let's get back to what you want to hear about today, and that is this amazing, spectacular Dragonfly mission. The video you're seeing might be a little slow and jerky just because it's through Zoom, and it's also kind of big on my PowerPoint. But what you should be seeing, I hope, and I'll send you a link later, you can go look it up, is Dragonfly descends down through the atmosphere of Titan. It gets released from its descent probe, and it just fires up and flies. It flies across the surface. It's got 4 sets of 2 blades all around the body. It's a drone quadcopter, rotorcraft lander is what we're calling it. It turns up an antenna, it communicates directly to Earth, samples the surface materials, and then picks itself up and flies again to the next destination. And it's really amazing. The time is now for us to be able to do this kind of a mission. It's taking our landed spacecraft one step farther, and really learning tremendous amount about the surface of Titan. So we all got together in September this last year after the mission announcement, and we probably look a little wide-eyed. We're all still kind of pinching ourselves, and we all look just remarkably kind of young. We're bright-eyed and bushy-tailed. That's not going to be true when we get there because we're going to the outer solar system, and so there's still a lot of waiting ahead. And I always wonder why are the Cassini team members so old? And well, it's because they've been working on this mission for as long as I will have been when Dragonfly gets there. But it's a great team. We're really excited. We have a wonderful PI, principal investigator. This is Zibby Turtle, and she's at the Johns Hopkins University Applied Physics Laboratory, which is where we had this meeting. What is it about Titan that makes this such a good opportunity? And really it's that we do not know how life came to form on the Earth, and we can't go back to study our own history. And let's all remember that the only place we've seen in the universe with life is planet Earth. It's almost certainly out there somewhere, but we haven't seen it. We've only seen life on Earth. And so we are groping around in the dark trying to figure out how are we going to recognize this when we see it on other bodies? And the best way we can think of is, well, let's think about what things were like on Earth and maybe look at the early days of Earth when life was just getting started. And so we look at these places in our solar system that might help remind us of early Earth. And it turns out that Titan is most like our planet in those early days, and it might hold the keys to understanding the origins of life. Here's a picture of Titan. This is the fourth one over that you can see in this image, and compared to the others at the right scale. Notice we've got very big Venus and Earth, and then about half that size is Mars, and Titan is just a little bit smaller. It's actually bigger than the planet Mercury, and it has a thick, dense atmosphere. It turns out it is the second densest atmosphere in the solar system compared to, or next to Venus. It has even more density than Earth's does, and it actually has about 1.5 times the surface pressure of Earth's atmosphere. And so it's really an interesting body. And not only that, its atmosphere is made mostly of nitrogen, just like Earth's. And the rest of it has methane and then a whole compendium of organic hazes. And by organic, we mean made of carbon and hydrogen, sometimes some nitrogen, but it is not necessarily made by life. It's just the same kind of materials that are used by life. And Voyager noticed this when it flew by in the early 1980s. And then we've been watching that ever since. And so it's been a really compelling, really exciting place for us to study. We've also learned that like the other icy satellites that all exist from Jupiter on out, it is made mostly, well, about half water ice, and then the rest is rock and metal. And so that means the crust, the rocks, the lithosphere are all made of water ice. And that is a rock at Titan's location in the solar system. It's very cold there, about 90 degrees above absolute zero. And then deep down in the interior, as you go down, you increase the pressure on that ice, and eventually it will melt. And there is an ocean of liquid water. And so just like the other icy objects in that part of the solar system, it is an ocean world. And this access to water is really exciting for us because, again, water is really important in terms of life in the way that we understand it. And so we're kind of following the water. We're looking for places where water is and just see if maybe the basic ingredients for life also exist and if life was able to start there. And finally, deep down in the interior, there are silicates and rocks, just like it'd be like the core of the moon draped in a mantle of water and ice. So we visited Titan with some other missions, especially the Cassini-Huygens mission. And here you can see it's gigantic. It's the size of a school bus. And you see the Huygens portion, which is by the European Space Agency on the right-hand side. This is tacked onto the side of Cassini and then was released down into the atmosphere of Titan. And no presentation is complete without a rocket launch. So hopefully you can see this right here.
7, 6,
take a drink while we're waiting.
5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a 30-mile trek to Saturn. The program is in. Roll program is in. We have 3 hours. The spacecraft is on its way to Saturn. Sequence 27. Systems are go. Station acquiring base.
Okay, those of you with the sharp ears know that that's from the abyss. But I think it's so special that this could launch at night and got to go up through a cloud and kind of light it up like a lantern. It's a really beautiful launch. This was before my time. I actually wasn't aware of Cassini, so I didn't get to see the launch. But it happened in 1997, and finally it arrived at the Saturn system in 2004. And I love this image of Saturn taken from behind it. Basically, you know you're in a spacecraft because the sun is on the other side and illuminating the rings, illuminating the atmosphere. And this image mosaic from Cassini can show that really clearly. And if you look kind of off in the corner of the rings here, up in the upper left, I don't know if you can see my cursor here, but if we zoom in on that, it is actually the Earth and the Moon. And that helps to kind of place us in the solar system and let us know just how far away from home we really are. The other moons of Saturn are also really exciting, and they have a lot of lessons for us in the solar system. One of the most interesting was Enceladus. gushing geysers of water out into space. And my artist friend, Mike Carroll, I'm sorry, I don't have an image credit on here for him. Mike Carroll painted this for me. He took my image that I took in Antarctica. This is my teammate Minako carrying my computer case, and put me on the surface of Enceladus. And sure, I would love to sometime. I hope that can work out. And so as we arrived at Titan, the Huygens probe was released and descended down through the atmosphere and landed on the surface. And it actually landed in a kind of dry, dusty riverbed. That's the middle image that you see here. Do you see the rounded rocks kind of rolled around in the bottom of a river? The rocks have got to be made of either water ice or organic materials. Again, they're not silicate rocks like we're used to on the Earth. And there's a picture of the Apollo astronaut footprint just for you to kind of get a sense of scale. And as we were descending, we noticed a myriad of river channels, these dendritic networks, really well developed, that tell us that there is rainfall and erosion on the surface today. And this is from methane rain. It's so cold at Titan that methane is a liquid, and it forms the liquid that rains onto the surface and fills up lakes and seas. And so we're starting to think that, you know, hey, the materials are all different, but the landscapes and processes are the same. And so we can use Earth's landscapes that are similar to these to help us better understand what's going on Titan. And here's a picture of another really interesting landform. This is a lake or a sea called Ligeia Mare on the surface of Titan. And we're looking at a radar image, and radar records things that are flat, extremely flat as dark. And so all the dark features here we think are just really flat liquid. And it's liquid methane that's filled up the rivers that are feeding into that lake and the lake itself. And in this radar image, we can actually see an impact crater. This feature, there are impact craters on Titan, but not very many because the surface is pretty young. It's been erased by erosion and tectonism, maybe some volcanism. But this, you can see the bright rim, kind of half of it all the way around here. It's about 450 kilometers in diameter. And this middle peak ring, and these are all just rugged mountains that have been eroded by methane rainfall since then. And the exciting thing about an impact crater is that the impactor smashes into the surface, which is water ice. It would melt that water ice and it would pond up in this area that you can see is relatively kind of low-lying and flat, and this would have been a big melt sheet of water. And that could have interacted with the organics that are on the surface. Some of them we can see here in these dark stripes. You see these dark stripes everywhere. In other regions we can see them too, and it turns out they are sand dunes. Hundreds of thousands of sand dunes all across the surface of Titan. And the reason they're dark in this radar picture is that the grains are really fine. They're a sand, but instead of like a silicate sand like we're used to on Earth, like quartz, this is organic sand. And these organics come from up high in the atmosphere where the methane is broken up, it recombines into the organics, and they settle down to the surface where they are blown into sand dunes. And it could be there are some intermediate steps, like there's erosion of some organic layers, creating those big cobbles you saw in the riverbed for Huygens, and maybe creating finer and finer particles, these sands that get blown into sand dunes. And that was a real mystery. We kind of thought, yeah, how could we have sand dunes all over Titan? We didn't even predict that. And here you can see in an infrared camera, the visual and infrared mapping spectrometer shows as brown in this particular image stretch where the sand dunes are, and they're all found in the equatorial regions of Titan, with the exception of the upper right corner, which is a bright blue water ice continent called Xanadu. And nothing encroaches upon Xanadu, but otherwise we find the dunes everywhere. And as we look closely at them, we realize that in size and shape and behavior around topographic obstacles, they are exactly like the sand dunes in the big deserts of Earth, like these here in Libya. So in the Sahara, in Arabia, in Southwest Africa, and Australia, we find this kind of sand dune. And so we have determined to go out and study these sand dunes in as many locations as we can. And here we are in Namibia, in Southwest Africa. We've just dragged a ground penetrating radar instrument up to the top of the sand dune. It's taken us a couple of hours, and then we'll go back down the other side. And we're coming up with an interior structure of the dune from this radar, this ground penetrating radar, that helps us understand which way is the dune moving over time, which way are the sands moving, and then we can apply those findings to Titan. In the United Arab Emirates, we find a really unique condition, and that is that in the interdunes, the area between the dunes, there are actually liquids. And these liquids are not all that friendly. They're very salt rich, and yet you can see some regularly spaced mounds in the background. Those are algal mats, and the algal mats form even in the salty waters in these hyper-arid conditions. And so we wonder if we could find, you know, maybe some liquid methane in between our big sand dunes, and that might form an area that is conducive to life. Okay, we have some other features on Titan that are really interesting. If this is almost inscrutable. This is a really strange image, but you can see some mountains that have been eroded. And if you look in the right, kind of the upper right and the lower right, you can see some parallel straight features. And this isn't an image artifact. These are real. These are actually exist in the landscape. What would make something so straight and parallel? And we actually see similar features on Mars. And this is a much more close-up image of landscapes on Mars. You can tell now that these are ridges, and the ridges on Mars are carved by wind. Where would we be able to have wind-carved ridges? And it's in areas where there's just not much involvement by water, because eventually water will overcome everything and make it into a river channel that meanders across the landscape. But if there's no water, there's no rain, then the wind takes over and it carves everything into these long ridges called yardangs. And this word comes from China and that region, kind of the Western Turkmenish region of the world, where there are a lot of yardangs. And there are some in Argentina in the high kind of Altiplano Puna region. And we visited this area many times. You can see us kind of in the lower right corner here. And there are these big isolated towers that are being kind of destroyed by a couple of different wind directions, and big gravels are sweeping through the corridors. These features in Argentina are forming in soft volcanic ash, and here I am right in between a couple of them. And normally these layers in the ash would extend all the way across, but the wind is whipping right through and it has carved a corridor in between. And as it does that, it actually leaves behind some resistant materials, like there are these little cobbles poking out here. They make dados, or fingers, pointing into the wind. And here my student Jonathan is studying the orientation of all the dados so that we can put them into a wind model so that we can better understand what the winds are doing around the yardangs in order to sculpt them and form them. And my student Dylan is working on looking at the hardness of the yardang rock so that we understand what is the range of hardness that we can have to form a yardang, and then we can relate that to the kind of materials we find on Mars and on Titan. We really love being there. It's such a beautiful landscape. It's very high. I always have to practice being at that high altitude and manage that. And it's very dry, but it is spectacularly beautiful. And right now NASA is paying us to go out and try to figure out these landscapes. We're making real progress. We've also been to some yardangs in China. Here are our two guides that drove us out. You can see they're in some stacked lake bed clays, and you can see those regular kind of stripe shapes as we go off into the distance. And another artist friend of mine, Bill Dunford, placed me right on the surface of Titan studying these yardangs. So maybe one day I get to do that too. Okay, well, so let's talk a little bit more about Titan and about why it's so interesting and a place that we'd want to send $1 billion mission to. And basically it has got the key ingredients for life. So there's sunlight, and that sunlight comes and breaks apart methane and other molecules and allows that to recombine into long-chain organics. And those organics will sit up in the atmosphere. They will come down and form a haze a little bit lower in the atmosphere and ultimately settle to the surface, maybe form layers, and those layers get eroded into organic sedimentary rocks and particles and sands all across the surface. And then also we have liquid water, and this is because the crust is made of liquid water, and if an impactor comes in and smashes into that crust, it will melt it and bring liquid water to the surface to interact with organics. Or we might even have cryovolcanism, liquid water that's coming up from deep in the interior and arriving at the surface. And so we've got that key fluid, but not only do we have water, we have a second fluid available, and that's methane. And the methane makes clouds and rain and rivers and lakes all across the surface of Titan. And it could be that methane could actually substitute for water many of these critical life-forming processes. So really only on Titan can we study this full range of the prebiotic chemistry that is possible leading up to the advent of life. And not only that, we can go to a lot of different areas all across the surface using our rotorcraft, and thereby being able to sample all of these really critical regions. And now is the time for this. We really have improved in our drone technology that we're ready to send something out to outer space. And Titan is really easy to fly in. It's actually 4 times denser than Earth's. Remember, it's 1.5 times the pressure, but because of the low gravity that you can see here, and it makes the atmosphere very extended, and so it's much more dense at the surface. And the low gravity also reduces the amount of power we need. So it's the perfect place to fly. And it turns out that this thing is actually really big. So I'm holding one blade right here, and there are 2 blades on either side of each of these rotors. So there's 16 total blades all the way across this aircraft. So, I mean, it's as tall as I am, it's a couple of me wide, and is really a spectacular machine. It's gonna fly directly there, and just remember from the video, it will just open that shell and drop and just start flying. And so that minimizes all of the things that we need. There's not gonna be an orbiter. We communicate direct to Earth and simplify things that way. It's gonna take a while to get out there. So once again, we're gonna be very used to waiting. We're gonna launch in 2026 and arrive at Titan in 2034. But there will be a lot of things to do during that time, some testing and preparation, operations that we'll get all ready. And I hope we'll be going out and visiting landscapes that will prepare us for what we'll see on Titan. The first place we land is going to be perfect in terms of having all the things that we want. There are big sand dunes there, and there is, so that's access to organics and these dunes and interdunes that we've been talking about. And here's a picture of us visiting the interdunes of Namibia. And you can see the really big kind of orange sand dunes pouring off into a river valley. And the interdunes between them are quite different. So we're continuing to, we'll be able to see that difference on Titan. What are the interdune areas like compared to the dunes? And we really hope there will be some liquids in some of those areas. And not only that, we're gonna land kind of next to an impact crater. And that's all the bright regions that you see here. That's the ejecta blanket around this impact crater. And that means that there should be some liquid water that has interacted with organics on the surface. And we can see what those interactions may have produced. We can actually operate on the surface for more than 2.5 years, which is so exciting. In between each flight, there might be tens of kilometers. And so we can go a total of a couple hundred kilometers over its lifetime. It's really taking the kind of rover idea of surface exploration to a whole different level. And we'll just be able to understand Titan like we never have before. We're gonna have a really interesting leapfrog strategy to be able to explore these areas. So we'll have a kind of safety base where we first land. And from there, we'll go out and overfly an area and then come back and land. And we can take a while to analyze that area. We'll spend most of the time on the ground, and then we can decide where the best next place is to go and land. And while we're on the surface, we're actually going to be making a tremendous amount of measurements in situ. We have a lot of really great instruments. The first is the mass spectrometer. And this Draco drill is actually going to drill into the surface through the legs right there and suck materials up into this mass spectrometer to be able to analyze them in situ. And then there is these 2 dots, the forward-looking gamma ray and neutron spectrometer, which will fire particles at the surface and help us understand the surface makeup kind of remotely. And then we also have a meteorology package that helps us understand pressure and temperature and wind speed. And we also will lower a seismometer from the Japanese Space Agency onto the surface and get a good sense of what's going on in the interior of Titan. And finally, we've got cameras upon cameras. We will have cameras for the flight, cameras for the ground, and really be able to characterize the area that we're looking at all across the surface of Titan in very great detail. This mass spectrometer will give us a huge amount of resolution on the makeup of the different particles we're looking at. And here you can see heavier and heavier particles that we'll be able to detect. And we'll use a couple of different methods. There's that laser desorption mass spectrometry, is kind of a broad survey of what things are. And then this gas chromatography can tell us specifically what molecules are there. and will even give us a sense of chirality. And remember hearing about that, that's sort of a handedness of organic molecules. And life on Earth prefers a certain handedness. And so wherever we see an abundance of that handedness, we know something has organized it into that. And so we'll look for that on Titan. Is there 50-50 chirality, or is there a preferred chirality that might indicate that life or something is organizing that on the surface? What I'm most excited about, though, is just to look at the landscapes in great detail and better understand what we're seeing, both from the air. We can see the ripples on the dunes and understand that they're actively moving, and see the crest lines, their orientation to tell us the wind direction. We can see on the surface what's the difference between the dunes and the interdunes, and we can even get up to this microscopic scale. And that middle image that you can see is from the Bagnall Dunes on Mars, from the Curiosity rover. And when I first saw that, I think I gasped. I was just floored that we could actually get a handful of sand on another planet, because sand tells us everything. It's kind of the end result of all the processes in the area. It tells us materials available, what's happened to them over time. And so what I'm dying to get is that handful of sand on Titan, and it sounds like I'm going to get it. So in conclusion, for this mission, really Titan is just offering us the next step to answer these fundamental questions, which is, what makes a planet habitable? What chemical processes led to the development of life, and has life developed elsewhere in our solar system? And Dragonfly will be able to answer all those questions. And here's a little bit more about Dragonfly. You can even just Google Dragonfly Titan, and it will bring up that Johns Hopkins University Applied Physics Lab website, and you can get to all those videos that I showed you before. So thank you so much for coming on this little journey with me, and for watching. Thank you for being fans of NEAF and for helping them out at this time, and also thank you to NEAF for bringing us all here and helping us be able to communicate with each other. It's really an amazing opportunity. Once again, I look forward to meeting you in person. I look forward to keeping up with you about Dragonfly and about all the exciting things that we're doing. And everybody stay safe, stay healthy, and keep looking up at the skies. The skies are still there for us to look at and enjoy every night. And if we do that, we can kind of keep ourselves sane, I think. So, all right, I will talk to all of you soon. Thank you so much for watching. See you later. Bye.
Hey everybody, Scott Roberts and Mike Hatch here at the Explore Scientific showroom for NEAF, the virtual experience. And we're here to talk a little bit about our 16-inch truss tube Dobsonian.
Oh yeah.
Which is what? It's going to be the
door prize.
The door prize.
The door prize.
Right. And so this is an ultra portable, easy to assemble telescope, valued at what's the normal value on this?
Normal value is $31.99.
And we're gonna be giving a NEAF special on this for $24.99, but you might win it here at this event. I mentioned that this telescope is really easy to assemble. We have a little video here just to kind of show the major assembly of this telescope. When it's all assembled though, the thing that's really cool about it is that it pretty much stays collimated. But the collimation of it's pretty easy to do. And what do you use, Mike?
Yeah, so with the Dobsonian comes with the collimation tool, and it is an easy one-person collimation job. Literally, you can take this tool down there, collimate your primary mirror.
Right.
And you've got some adjustments for your secondary mirror, but other than that, you'll be ready to go.
It's all no tool knobs and stuff. Now,
is.
on normal Dobsonians, you're gonna be back here making adjustments to the mirror. You might have somebody over here saying, is the laser lined up, or if you're doing a visual collimation, checking it and adjusting it. But this can be done with one person.
Right.
And that's really unique to this design. So this is a part of a family of telescopes that runs from a 20-inch telescope all the way down to a 10-inch. So we've got 4 models, all available from Explore Scientific and from our dealers here that we'll be highlighting for the NEAF special.
Right.
Anyways, guys, we have a lot more to show you. We're real excited to be here participating in NEAF, the virtual experience, and stay tuned for more.
Ready for a new kind of telescope experience? Unlock the power of your smartphone to help you navigate the night sky. Introducing StarSense Explorer by Celestron. It's fast, easy, and accurate. In minutes, you're ready to take a guided tour of the universe. First, dock your smartphone and launch the StarSense Explorer app. Unlike other astronomy apps, StarSense Explorer aligns precisely with your telescope and uses sky recognition technology to pinpoint its exact position in the night sky. Follow the simple instructions, and in seconds, the app generates a list of all the best objects currently visible in the night sky. Select an object from the list and follow the on-screen arrows to the desired object. As you move the telescope, StarSense Explorer recalibrates its position in real time. The bullseye turns green when your object is ready to view in the eyepiece. It's that simple. StarSense Explorer works anywhere in the world, no cell signal required. So whether you're in your backyard or a remote dark sky location, the universe is yours to explore.
From the time it took Voyager to leave the Earth and reach the edge of the solar system, I went from being a baby to a high schooler to a university graduate to a worker to a business owner, and now I'm a husband, a father, a postgrad student, a science communicator, a musician, a YouTuber, and a backyard astronomer. I've been lucky to reach this point to be able to buy some of the best equipment an amateur astronomer could dream of. But there's one thing I can't afford, and that's time. Astronomy has made me a more patient person, and the constant drive to get better and collect more data to capture the wonder of the cosmos is something I have to balance with everything else in my life. So when I see a telescope with a lower F number, I know that its value to me is far greater than money alone. A telescope's value is not just the sum of its parts. It comes from how much you can get it outside and how much you can get out of it. That's why I jumped to buy the Celestron RO Ackerman Schmidt Astrograph 11. Its 620mm focal length at f2 allows me to capture the incredible southern hemisphere nebulae, sometimes within a single night, but always with revealing depth and signal. I've been shooting the universe with the RASA 11 for years now, and it's allowed me not only the satisfaction of sharing these unique views from my end of the world, but also to detect and track asteroids, which is an area I'd love to explore further. The RASA 11 easily crosses that divide between a consumer scope and a scientific research-grade observational telescope for discovery and analysis. The real limit for the RASA 11 is really how far I'm willing to take it, and it's nice to have a telescope that I won't outgrow for a long time, because time is the only thing we don't get more of.
The QHY-168C is a high-performance, cooled camera with a low-noise, high-sensitivity, APS-C format Sony color CMOS sensor. A modified version of the QHY-168 is also available that has had the Bayer filter matrix and micro lens array removed from the sensor to produce a monochrome camera. Except for the modification to the sensor, the color camera and monochrome camera are otherwise identical. The heart of the 168C is the Sony IMX-071 Exmor CMOS sensor. The IMX-071 is a 16 megapixel, 14-bit, low noise, high sensitivity color sensor with 4.8 micron pixels. This is the same sensor used by Nikon in the D5100 and D7000 cameras. In the QHY-168C, this sensor has only 2.3 electrons of read noise at high gain. Even at low gain, the read noise is only 3.2 electrons, and the dynamic range is around 14 stops. Sony's Exmor technology increases the effective light grasp of the pixel by providing as much free aperture as possible for each pixel and using a gapless microlens structure to direct more incoming light to the photo sites. Physically deeper pixel wells are also more effective at capturing the longer wavelengths, increasing the sensor's sensitivity to red light and thus making the QHY-168C color camera excellent for capturing the H-alpha emission so common in many deep space objects. While the 168C has the same CMOS sensor as that used in the Nikon cameras, unlike the consumer cameras, the QHY-168C offers true raw image output. In the DSLR implementation, there is a raw image output, but typically it's not completely raw. Some evidence of noise reduction and hot pixel removal is still visible on close inspection. However, the QHY-168C offers true raw image output and produces an image comprised of only the original unprocessed signal, thereby maintaining the maximum flexibility for post-acquisition astronomical image processing programs. In addition to efficient two-stage thermal electric cooling, QHY-CCD employs a unique thermal noise control technology to reduce CMOS sensor noise to a very low value without affecting the integrity of the raw image. This proprietary technology can be found to improve noise performance across the whole medium cold MOS product line, yielding much better noise reduction than competing camera models. With the sensor cooled to minus 15 degrees, the QHY-168C dark current is less than 1,000th of an electron. With such low dark current and such low read noise, the QHY-168C is uniquely capable at taking both long exposures for deep space imaging and multiple short stacked exposures for planetary and other bright object imaging. Long exposures are further enhanced by the complete reduction of amplifier glow that can be problematic for some CMOS sensors. In the QHY-168C, there is zero amplifier glow, no matter how long the exposure time. Short exposures are enhanced by the fast frame rate of the camera. The QHY-168C produces high-resolution 14-bit images of the full field of view at 10 frames per second. For planetary imaging, smaller regions of interest can be recorded at up to 130 frames per second, depending on the frame size. The QHY-168C has a 120 megabyte DDR2 image buffer to cache the image and avoid the risk of a frame loss. The image data is stored in memory immediately after acquisition and then transferred to the computer from the memory buffer. This avoids problems of a busy USB port when there are other peripherals using the same port as the camera. The QHY-168C benefits from more than a decade of cooled camera design experience. QHY-CCD has implemented full anti-dew and anti-frost control solutions. Unlike DSLRs, the sensor in a dedicated astronomy camera is often thermoelectrically cooled to low temperatures in a sealed chamber to reduce the noise that otherwise accumulates in long exposures. Dew is moisture that condenses onto the outside surface of the chamber's window due to the cooling of the sensor inside the chamber. Frost, on the other hand, is moisture that freezes on contact with the inside of the chamber window when the temperature of the chamber is reduced below 0 degrees. To help prevent either of these conditions from interrupting your imaging session, the QHY-168C camera has an integrated drying port on the side of the chamber accessible by the user from the outside, where a desiccant tube can be attached to eliminate any moisture-causing frost in the chamber. A desiccant tube is included with the camera. Additionally, to prevent dew, the light shield over the chamber window is equipped with built-in heating elements to keep moisture from condensing on the outside of the chamber window. In order to avoid halos around bright stars, the QHY-168C has a multi-AR-coded optical window rather than the common IR cut window for single-shot color cameras. This permits full access to the red wavelengths of H-alpha and S2 without attenuation by the window coating. For RGB color balance, without passing the near IR wavelengths above 700 nanometers, a separate removable 2-inch UV IR filter with the desirable passband characteristics is placed in a custom filter holder in front of the camera. Each camera is carefully calibrated at the factory with a high-precision axis measurement device. Orthogonal placement of the sensor is guaranteed to be flat to the image plane to 20 microns across the center from edge to edge, so there's no need to adjust the camera tilt, absent mechanical errors elsewhere in the image train. The QHY-168C has a short back focal distance, allowing the use of QHY CCD's 0.5 mm to 27 mm spacers in step sizes of 0.5 mm for best flexibility in setting up your optical train. The QHY-168C is available from your favorite QHY dealer at the new lower price of $13.99.
Thanks for watching all of our videos, folks. Scott and Mike back again here in the Explore Scientific showroom. And we wanted to highlight two of the First Light series telescopes. These are our First Light Dobsonians. What can you tell them, Mike?
So our First Light Dobsonians, we've got an 8-inch and a 10-inch model. The 8-inch is an F6 and the 10-inch is an F5. They are equipped with oversized bearings to allow for some smooth adjustments. It also comes equipped with a eyepiece tray to hold all of your accessories right there, so you can just switch out as you need. And also tons of other accessories as well, such as 25mm eyepiece, red dot viewfinder, smartphone camera adapter, lots of really cool things.
So how does the smartphone camera adapter fit onto these scopes?
The camera adapter will just slip over the eyepiece, which is included, and from there you can attach your smartphone to the adapter and take pictures directly through the eyepiece that's installed on the telescope.
You can get a great shot of the moon with it, probably some planets. Because it's not a driven system, you're not going to be doing deep sky work, but lunar terrain is amazing, and it will give you a taste of this. If you want to get into astrophotography, the thing that's unique about these Dobsonians is that they already come with cradle rings, okay? And those cradle rings can be attached to a dovetail rail, which can then be slid onto an equatorial mount. So you've got a really versatile telescope system here, originally mounted as a Dobsonian, but can be made equatorial. So that's a great thing to look at when you're looking at what you'll be doing in the future. So anyways, what's the prices on these, Mike?
So with the 8-inch, it's typically $549, and the 10-inch is $749. But for the NEAF, the virtual experience, these will be on sale for 20% off.
That's a hot deal. So these are very popular. The 10's been a little bit more popular than the 8. People get aperture fever. So anyways, if you've got aperture fever, if you've got a smaller telescope and you're ready to step up to see some deep sky objects in all of their glory, consider the First Light Dobsonian telescopes.
Hi everybody, Dan Higgins again for Camera Concepts in Stony Brook, New York. Back here at NEAF, the virtual experience, and this is the deal that everyone's been waiting on. I think I just might have showed it by accident, but here we go. You know they're red. You know they got the letter Z in it. You know it's 10% off all images. It's ZWO. You want the 120 mini for your guide scope? 10% off. You want the 290 or 224 for a planetary? 10% off. You want the newer 533 with no amp glow? 10% off. All images, ZWO, 10% off. Come down to cameraconcepts.com. Hit us up at 631-475-1118. Give us a call at the store. We'll get you a ZW imager out to you right away. 10% off, NEAF special. Again, come visit us, cameraconcepts.com. Thank you so much for watching. Enjoy the rest of the show.
Hey guys, Mike Hatch from Explore Scientific. Here I am standing in front of our Truss Tube Dobsonian series. Within the series we have our 10-inch, 12-inch, and 16-inch Dobsonians. They're easy disassembly, easy assembly, and can be transported in a compact car. These telescopes are also equipped with an easy collimation system and the tool needed to do it. We've got a 2-speed, 2-inch rack and pinion focuser, battery-powered cooling fans, and a shroud available for each size, which is sold separately. So come and check out our Dobsonian series at explorescientific.com and keep looking up.
Westchester Amateur Astronomers is located immediately north of New York City. The club was founded in 1983 by a small group of amateurs and has now grown to over 200 member individuals and families. Our members generally hail from Westchester and Putnam counties, but we have members in the city, Long Island, Connecticut, and even one in Alexandria, Virginia. WAA's monthly lecture series at Pace University in Pleasantville presents speakers from a wide variety of academic and professional backgrounds. Among the recent speakers were Charles Lawrence, the Chief of Astrophysics at the Jet Propulsion Laboratory and U.S. Head of the Planck Project, Michael Tutz, Chairman of the Department of Physics at Columbia and U.S. Head of the Atlas detector at CERN that discovered the Higgs boson, astrobiologist Caleb Scharf, author Davis Sobel, and Carter Emmert, Director of Astrovisualization at the Hayden Planetarium. Our star parties are held at the Ward Pound Ridge Reservation in Cross River, New York, one of the darkest sites in the county. We observe on a paved parking lot with good exposure in all directions and capacity for more than 40 telescopes. We schedule one event with a rain-cloud postponement date each month when the moon is not going to wash out deep sky objects. Star parties are open to the public, and we often have groups from local schools, scout troops, and even an annual observing session with Fordham University astronomy students. Members bring a variety of instruments, and the club's 20-inch Obsession telescope, recently fitted with encoders, sometimes makes an appearance. Through a special use permit with the Westchester County Parks Department, WAA members can observe or image on non-star party nights with advance notification to the park office. WAA is frequently requested to provide outreach programs for libraries, schools, and community groups in Westchester County. These include viewing sessions, lectures, and demonstrations. Some of our members like to do spontaneous sidewalk astronomy in the various towns in Westchester. Our enthusiastic membership is always eager to reach out to the public. WAA's monthly newsletter, Skywatch, is a serious publication of articles and images by members. We think it's the best newsletter of any astronomy club in the country. Our website, www.westchesterastronomers.org, provides members and the public with up-to-date information about coming club activities, directions to our events, and the archive of newsletters going back to 2006. We send frequent emails to members to keep them updated about our activities, as well as other astronomy-related events. Like you, we're really going to miss NEAF this year. WAA has had a booth since 2012. Almost 24 members volunteer to help staff the booth during the show, and many more stop by. We have an annual picnic that features lots of food and drink, good camaraderie, door prizes, solar viewing if the weather permits, and even an astronomy quiz with prizes to the winners. Our members travel widely and present their experiences to other club members at the September club meeting called Members Night. WAA is probably the only astronomy club this side of the Oort cloud that has an official vice president of confections. Eva Anderson's cookies are a hit at our lectures. She baked special solar eclipse cookies to commemorate the 2017 eclipse. About a fifth of our club members travel to see totality. Many of our members are avid observers, photographers, and astro travelers. We like to teach. And we like to help each other out. Annual dues are only $25 for an individual or family. If you live in or anywhere near Westchester, please consider joining us and becoming part of our WAA team. Thank you for your attention, and enjoy the rest of the virtual NEAF this year.
Hi everyone, Dan Higgins here from Camera Concepts and Telescope Solutions in Stony Brook, New York, and thank you again for joining us for NEAF, the virtual experience. So here we go. Our next set of deals is Celestron. So Celestron, what we have for you is the C-Gem 2 mount at $150 off. Well, what is a C-Gem mount good for? Well, it starts off with a 40-pound payload capacity, which is good for pretty much if you're just starting off with astrophotography, or if you're doing some heavy-duty visual. It's also got a latitude range of 15 degrees to 70 degrees. So pretty much anywhere you are, it's going to be good for what you need. It's also got a nice 2.0 port USB at the bottom of the hand controller, so you can connect it to your computer through your ASCOM drivers. Don't forget the ASCOM drivers. You're going to need them. You astrophotographers out there, you know what I'm talking about. Also, it's got a dual-fit dovetail saddle. So whether you got the V-style dovetail or the D-style dovetail, you're good to go. It's also got a trainable periodic error correction, which is really good when you got those little minute issues with tracking and your gears are a little bit off. It's trainable, so you can fix that. So Celestron, $150 off the C-Gem 2 mount. Come to cameraconcepts.com. Here's our phone number. There's our website. Thank you so much. Come on down. Thank you for joining us for NEAF, the virtual experience. And don't forget, Celestron, C-Gem 2 mount, $150 off. Thank you so much.
Ladies and gentlemen, this is Daniel Mouncey, aka Dr. D, and today we have a Takahashi TOA 150. And I'm just going to tell you a little bit about Takahashi. They have a vast array of astrographs and visual refractors. The visual refractors are like the FC100DC, the DF. They also have a new one called the DZ, which uses, they all use fluorite. Those ones use fluorite. The beautiful thing about the DZ is it's the first doublet I've ever tested or seen that is literally color-free, which is just amazing. And I think TACA has really raised the bar with that telescope. There's also the Epsilon series for the astrographs if you want. These are beautiful little Newtonians. They also have the Epsilon 180, the 130. They also have the FSQ 85, the FSQ 106, the FSQ 130s. These are beautiful astrographs, and the quality is really up there. This TOA 150 is like the flagship triplet refractor. There's also the TOA 130, and it just goes on. They have Dalkirkham Cassegrains from the Mulan 180 to the Mulan 210 to the Mulan 250 and the Mulan 300. They even make a 16-inch, but you only see those in Japan usually. But these are really the standard of excellence. Check these things out. And if you have any questions about them, I can tell you all about Takahashi all you want. Visit us at telescopes.net, or you can call us toll free at 888-427-8766 and ask for Dr. D. That is me.
Hello, everyone. You're watching NEAF, the virtual experience on NEAF TV.
Hi, this is Marcy from Takahashi America. On behalf of all of my colleagues at Takahashi, I send our well wishes to you all and our thanks for joining us for virtual NEAF. We also salute every member of Rockland Astronomy Club. You guys have truly gone where no astronomy club has gone before, and we are impressed. In this segment, it's my pleasure to bring you a very special announcement from Takahashi. I will also share with you the details of a special limited time only sale in honor of NEAF. Let's begin with a special announcement from Takahashi. Takahashi is announcing a limited production of the TSA 120N. This anniversary edition will include a micro edge focuser and fixed dew shield. This run will be limited to just 30 units worldwide, so if you find this of interest, please act quickly. The TSA 120N will be available from any Takahashi America dealer. Also, Takahashi is finalizing an upgrade to its EM series of mounts. The new system will be called TEMA 3 and should be released this summer. The first model upgraded will be the EM11. It will feature 3 slew speeds, up to 1000x sidereal, among other new features. Follow Takahashi America on Instagram and Facebook for updates later on this spring. Next, let's talk about a 3-part NEAF sale from Takahashi America. These sale prices are available this weekend only. Let's begin with 10% off all FC series optical tube assemblies. This includes all of the FC76 and FC100 models. Click on the links below to learn more about these telescopes. Secondly, we are announcing 10% off all Epsilon series optical tube assemblies. This includes both the Epsilon 130D and Epsilon 180ED models. Lastly, we're offering 10% off Takahashi eyepieces, extenders, flatteners, and reducers. Details on all of these sale items can be found at Takahashi America and from your local dealer. In our next segment, you'll get the rare opportunity to hear from our Takahashi colleagues in Japan. Stay tuned, and thank you for watching.
Hey everybody, Dan Higgins over here at Camera Concepts and Telescope Solutions out in Stony Brook, New York with my co-host Pepper. How you doing? We're here at NEAF, the virtual experience. We got a lot of stuff for you, but let's get down to Explore Scientific. Explore Scientific. We have a lot of deals on telescopes. So let's start off with the 102 and 127 millimeter telescopes. For these telescopes, we got the regular doublet, the Acromats, $100 off. We got the Essential Series, $200 off. We got FCD 100 glass, $400 off. If that's not enough for you, we got 20% off on select mounts, telescopes like the First Light series, and also eyepieces and filters. So come on down to cameraconcepts.com, take a look and see what we got. Here we go. Our phone number's on Pepper's side over here. and then you come on down, you take a look and see all the deals we got on Explore Scientific. So thank you so much for joining us for NEAF, the virtual experience, and we'll see you out there very soon. Thank you.
Hi, I'm Dave Eicher from Astronomy Magazine. I'm here with
Dina Johnston, also with Astronomy Magazine.
and we're very regretful and sorry that we won't see you at NEAF this spring. It's our favorite telescope show. We look forward to seeing all of the vendors and all of our great customers every year, catching up with you all. It's not going to happen. We hope you'll enjoy the virtual show, though, this year, and we will really look forward to seeing you September 12th and 13th in New York when we put it on again. So hang in there, enjoy the show, have a great summer. Dina, anything to add to that?
No, I just was looking forward to seeing everybody in the spring, but now I'm looking forward to seeing you all in the fall.
Take care, folks. We'll see you soon. Have a good NEAF. We love you.
Bye-bye.
Welcome to Starlight Express here in the UK. This is a brief video for our presentation for Virtual NEAF for 2020. What I'd like to do is give you a very brief explanation about the company. We're a UK-based design and manufacturer, so all the cameras, filter wheels, active optics, spectrographs, etc. are all made here in the UK in our factory to start with. Our CCD cameras, our new Pro series, which we released about 9-10 months ago, they have even better electronics and even lower read noise than our existing cameras. The read noise is typically around 3.5 electrons, which is the same as most CMOS cameras. Most CMOS cameras tend to quote about 1.5 electrons, but that is at maximum gain. And at that point, your full well depth is reduced down to maybe only a few hundred electrons, maybe 1,000 electrons or so. Whereas with our CCD, whereas if they're used at their zero gain or unity gain, as we like to call it, the read noise is typically around 3.5 electrons. The main advantage, therefore, with CCDs over CMOS is that you can bin the pixels. So if you have a short focal length telescope and you've got a camera with maybe 3 or 4 micron pixels, you can then transfer that over to a slightly longer focal length system, which has maybe which requires something like a 6 or 7 or 8 micron pixel camera. You can bin the pixels 2 by 2. Most CMOS cameras can't do that. They tend to have to bin it within software, and when you do that, you're actually not gaining as much as if you do it in hardware, because although you're doubling the pixels, you're also doubling the read noise as well. So our CCD cameras will typically outperform most CMOS cameras, both present and we believe in the near future. So please look at these carefully and compare CMOS and CCDs alike. CCDs still have a very big part to play within astronomy and other scientific applications as well. So our most prominent CCD camera is probably the Pro 694. Now these have a Sony 6 megapixel camera, about 4.5 micron, 4.54 micron pixels. They are incredibly low noise. We're talking about 3.5 electron read noise, but we're also talking about 0.001 electron at -10 degrees. So we can actually take typically half-an-hour exposures without having to worry about dark frames, etc. The other great thing with our CCD cameras is they're incredibly lightweight. They are typically only about 450 grams, so less than a pound in weight. I have been known to juggle these, but these are actually live cameras, so I won't do that just yet. The cameras have a built-in USB hub. We have USB 2 connection and 12 volt DC input. The 12 volt DC, typically the cameras only take about 1 to 1.5 amps at 12 volts DC. So if you are doing this remotely, then this will quite happily sit on a car battery all evening, probably for 2 or 3 evenings, without having to recharge the battery. The front plate on the cameras is actually movable, so if you have any collimation issues within your whole optical train, you can actually adjust the front relative to the CCD to take out that collimation issue. All of our cameras have fused silica or sapphire windows. The advantage of that is the fact that as the body warms up, the heat transfer properties of fused silicon and sapphire are very, very good, which means that the front window actually warms up a little bit too and stops dew forming on the front window, which is generally quite a common problem with cooled cameras. We also have a argon filled CCD chamber, so there's no moisture inside at all, and also you don't have to worry about changing desiccant out or taking it apart to dry it out. This is a completely sealed system. We have a small fan in the back here which draws air through some holes in the front section and expels it out the back, which means we can get typically about -40 to -45 delta from one of these little cameras, even in such a small compact form.
Hi, I'm Dina Johnston with Astronomy Magazine, and this is
Dave Eicher with Astronomy Magazine.
And we wanted to let you know about a special offer that we are giving all virtual NEAF attendees. You will receive $10 off a purchase of $20 or more on our website. We have dozens of astronomy and STEM products that would be of interest to your entire family. These products include our Pluto and Mars globe, our meteorite kit, also our constellation cards, and our 3D printed asteroids, among many other products which you can see here. To receive your $10 discount, go to myscienceshop.com/NEAF. When you're checking out, use coupon code NEAF20. And once again, that's coupon code NEAF20. Thank you again for participating in the virtual NEAF. We look forward to seeing you in September at the rescheduled NEAF show on September 12th and 13th.
Hi everyone, Dan Higgins again at Camera Concepts in Stony Brook, New York. Thank you so much again for visiting us at NEAF the Virtual Experience. We have our next Camera Concepts exclusive, the Arcturus Binoviewer sale. First time ever on sale right now for $169.95. Well, what does this offer you that other places don't? First of all, the Barlows that it comes with is at 1.85 and 3.0, so it comes with 2 sets of Barlows. Awesome. So you got nice 2 different sets of magnification there. There's no set screws with the eyepiece. They're held by the brass compression rings, which is self-centered to keep the eyepieces in good collimation, which is really important, especially when you're dealing with, 2 eyes. You want to make sure that everything is good. It also comes with an individual diopter for each eye. So some of us, like myself, one eye is a little bit out of whack than the other one. You can change the focus on both of them. So it's really, really good deal at $169.95. The Arcturus Binoviewer first ever sale. Come on down to cameraconcepts.com give us a call at 631-475-1118, and we'll take care of you. We'll get you hooked up with those nice 3D views that the Bino Viewers gives you. So again, cameraconcepts.com, 631-475-1118, and thank you for watching, and enjoy the rest of the show.
First Contact Polymer is a safe and easy-to-use strip coat cleaning system that removes dust, fingerprints, residue, and contaminants from precision surfaces.
Hi, I'm David Giesen from Photonic Cleaning Technologies, manufacturer of First Contact Polymer, and welcome to our NEAF virtual demonstration. We want to do a couple demonstrations for you and also answer a couple of questions that we're often asked. We'll do the demonstrations in a moment, but I'll do the questions now. The first question we're often asked is it safe for my coatings? And the answer is yes. First Contact has been used all over the world. Some of the largest telescopes in the world, including the WM Keck telescope. It's also been used on LIGO optics, arguably some of the most precise optics in the world, and nearly all of the DoD manufacturers. The second question we're often asked is, how much do I need? On our website, there is a handy use chart that shows the amount of polymer required for a given diameter. Our Red First Contact regular all-inclusive kit is an excellent choice for all refractors and most reflecting optics, especially those under 10 inches in diameter. But if you do have a question about which kit to choose, please feel free to contact us. So this is a couple of the demonstrations we want to do for you that we get often asked when we're at trade shows is, how do you apply it? So the first thing is I will show you what not to do. What you shouldn't do is take your 15 ml applicator bottle or even a 30 ml and dip and brush. That's not how you should apply it. The way you should apply it is either to pour it on as such, either out of a 15 ml or 30 ml, or you can also use a pipette if you bought a kit that has a pipette, and you can use the pipette. This is obviously much more of a controlled application, and you can put on what you need. Once you've done your application, then you can use your brush. In this case, I'll use the small one here, and spread the polymer using its surface tension, so that your idea is you're not touching the surface of the mirror or optic. The next thing we will demonstrate is how to do a spot cleaning in the center of a mirror if you've got a bug spot or unfortunately a fingerprint or something like that. So one of the other demonstrations we wanted to do is if you have a spot in the center of your mirror or your corrector plate, you can just apply polymer to it, to that spot, embed your mesh. These processes have all been shown in other videos on our YouTube channel. Once it dries, you just grab your mesh, peel it off, and the spot will be clean. And our last demonstration is just to point out, if you're working on a Schmidt-Cassegrain type telescope with a corrector plate, avoid this area here where there's a fibrous gasket sandwiched between the secondary mount and the plate. If you get the polymer on it, it will absorb into it and it won't easily just peel off. It'll probably leave a little residue on that gasket. So you can either avoid it by staying a 1/4 of an inch away from it, or use an O-ring as demonstrated on some of our other videos. The same applies on the inside to this baffle tube assembly down here. You want to avoid where the baffle tube is mated to the mirror. Obviously, if you have an open truss style, it's a lot easier for application. And if you have a Dobsonian or Newtonian, you don't have to worry about that. But those are areas that you should avoid getting the polymer, because it will wick in and won't just peel out. Thank you for watching our demonstration here. We encourage you to go to our website and visit the testimonials page to take a look at what other people are saying about First Contact Polymer, and to take a look at some of the photographs. And also to go to our YouTube channel. Just look up Photonic Cleaning Technologies and take a look at the videos we have uploaded. Again, thank you for attending our NEAF virtual demonstration, and we hope to see you in September.
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be, and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
Mission Operations Manager, better known as Mom.
It's great to be here. Thank you. Wow, there are a lot of people. What a great conference.
Friday, I was the launch chief engineer, and that means that I'm really busy with the mission.
No one has ever seen before.
Welcome back to NEAF, the virtual experience. Our next speaker, Dr. Alex Young, is NASA's Associate Director for Science and Heliophysics Division. Joining NASA as part of the European Space Administration SOHO mission, Alex is currently engaged with the Parker Solar Probe. Please welcome to NEAF, the virtual experience, Dr. Alex Young.
Hello, I'm C. Alex Young, the Associate Director for Science in the Heliophysics Science Division at NASA's Goddard Space Flight Center. I'm sorry we can't be in person, but I'm excited to be able to give you this presentation virtually. Today I'm going to talk about the Parker Solar Probe and arguably a new golden age of solar physics. You know, the sun that we see every day can be beautiful, or more likely its effects can be beautiful, sunrises and sunsets, but it's not too exciting of an object. And in fact, it's actually really too difficult to look at. It's so bright that we can't look at it with our own eyes. We have to use safety glasses, the same kind you use during a solar eclipse. If you take a picture with a regular camera, again, you just get this washed out image because it's just such a bright object. But it is, of course, our source for heat and light and very important to us. But there's a lot more going on. And on the Earth, with special telescopes, you can see a little bit more of what's interesting with the sun. But it turns out that during one special time, a total solar eclipse, we can actually see some amazing structure and see amazing dynamics in the sun's outer atmosphere, what we call the corona or crown. During a total solar eclipse, when the alignment of the moon, sun, earth system is just right, the moon nearly completely blocks out the sun's disk, its bright disk called the photosphere, and the outer atmosphere, the corona, millions of times fainter, now becomes opened up to our eyes. And in fact, we see structures, loops. These are caused by magnetic fields on the sun. You see these pink structures, which are actually pieces of the sun's lower atmosphere supported by magnetic fields up in the corona. And so total solar eclipses have been one of the first ways that scientists have begun to see the excitement and the interesting things happening in the sun's outer atmosphere. But we do have some amazing, powerful telescopes on the ground, but there are some types of light that we can't see here on Earth. Now, this is visible light, but types of light that's much more energetic, ultraviolet, the kind of light that gives us sunburns, or extreme ultraviolet, even X-rays and gamma rays, mostly doesn't make it through our atmosphere, which is great for us because it's not particularly good for our bodies. But that also means that we don't see the sun in these wavelengths of light, and we're missing a lot of interesting physics, a lot of interesting dynamics. So one of the things we do is we put a spacecraft with solar telescopes into orbit above the atmosphere, and this allows us to finally see a very different, unique sun. Here's a look at the sun in extreme ultraviolet, several wavelengths of light, much more energetic than visible light, light we can't see with our own eyes. And look at all the activity. You see that flash, that's what's called a solar flare, a flash of light covering the entire electromagnetic spectrum with enough energy to power the world for 100,000 years. And you see all these structures wiggling, and in fact, after that flash, you see material moving, and in fact, billions of tons of solar material are blasted into space, eventually filling the whole solar system. This stuff travels at millions of miles an hour. It carries the sun's magnetic field with it, and this type of energy and matter creates an incredibly complicated environment in the solar system driven by the sun. And in fact, as you go higher up in the sun's atmosphere, you see more and more structure when you look at higher and higher temperatures. These are more energetic wavelengths of light. So as we go to ultraviolet, extreme ultraviolet, and an X-ray, each one of these is moving higher and higher up in the atmosphere, and in fact showing us a higher and higher temperatures. The sun's surface is about 10,000 degrees Fahrenheit, but it quickly moves up to many millions of degrees as we move into the corona. this part of the atmosphere that we can see during a total solar eclipse. So this is one of the amazing discoveries and challenges for solar physicists. Why does the atmosphere get hotter as you move away from it? It certainly doesn't make sense when we think about a campfire. As I move away from the heat source of the campfire, it gets cooler, and that's not what's happening on the sun. But also, this atmosphere that's getting hotter and hotter escapes and streams away into space. Particles and magnetic field streaming away from the sun create what we call the solar wind. This solar wind and these huge eruptions of material we call coronal mass ejections, those flashes of light called solar flares, create an incredibly complicated environment, and in fact they create their own weather in space, what we call space weather. And all of that solar wind, as it expands out, we see in this animation of the solar system, creates this complicated bubble around the whole solar system. And that bubble is elongated as it's traveling through interstellar space. As those two interact, it creates a wake, like a ship traveling through the water. And you see this bubble moving in and out, almost breathing, and that's as the sun's activity increases, the bubble streams gets bigger, and as the activity decreases, it shrinks. This is happening over roughly an 11-year period called the sun's activity cycle. And all of that energy and matter is interacting with everything in the solar system, including our own atmosphere. And in fact, the solar wind and these solar storms, coronal mass ejections, interact with our magnetic field here on Earth and our atmosphere and create the northern and southern lights, the aurora borealis and the aurora australis. Here's an image of the southern lights from the International Space Station, the ISS, over the Indian Ocean. This is one of the first signs we have of this space weather interaction. And we're living in the atmosphere of a star. All of this material flowing out is creating this environment, and it's in fact the extended atmosphere of the sun. Here is a data visualization showing you particles from the solar wind, and in fact this giant huge cluster of particles from a coronal mass ejection. As they pass by the Earth, you can in fact see that the particles are moving around the Earth because some of them are being deflected by the Earth's magnetic field. It's acting as a shield, and these particles, which react to magnetism and electricity, move around it. Well, back in the 1958, we launched one of our first rockets, the beginning of the space age, into what's now called the Van Allen radiation belts. A rocket with a Geiger counter sending up a spacecraft headed by the team led by James Van Allen showed us the first glimpses that space was not empty. In fact, it was radioactive, full of all of these particles and energy. And scientists at that time decided that there were many questions that we needed to answer. So they put together a bucket list. And this bucket list had all of these different achievements we wanted to make, one of which was to send a spacecraft to the sun. And in fact, around that same time, a young scientist named Eugene Parker theorized that this expanding atmosphere of the sun created what we call the solar wind. This was something that at the time we didn't know about, and Parker theoretically predicted that it existed. And in fact, a few years later, we discovered for the first time real data validating this theory that was once maligned by many scientists as not being realistic. And so this led to the beginning of the works of Eugene Parker, who provided incredible science and insight into the workings of the sun and how it interacts with the solar system, what we call the whole field of heliophysics. And in fact, some of the same physics applies to stars outside of our own solar system. But one of the big questions is, why hadn't we gone to the sun yet? Well, the main reason is technology. And within the last 10 years, a project called the Solar Probe Plus was in development because we finally had made these technological leaps. So going from 1958 to now, the technology needed for the solar probe to become a reality was like a leap from a rotary phone to an iPhone 10 or an iPhone 11. So this was a monumental step in technology. One of the big issues was thermal protection, heat. The sun is really intense, and as you get very close to it, the heat that the spacecraft experiences is extreme. You can imagine going out on a really hot day, how hot the sun is. Well, imagine if you are much, much closer, if you are feeling the much more intense sun. And in fact, on its closest approach, the heat shield would experience a temperature of 2,500 degrees Fahrenheit or 1,400 degrees Celsius. So scientists and engineers developed a heat shield made of carbon foam, carbon fiber composite that protects all of the instruments. They all sit behind it except for one of them made from special material to handle the intense heat. And the only other thing that sticks out are the solar panels, which I'll mention in a second. But just to give you an idea, if you look up in the sky, the moon is about a half a degree in the sky, the apparent size, and the sun is equivalent to this roughly. And when we get to the location that the solar probe is getting to, much, much closer, the sun actually is 14 degrees in size. So around 28 times bigger. And in fact, the intensity is about 500 times more intense. Incredibly huge amount of light. And that light hits the front of the spacecraft and heats it up. So while we're close to the sun, we have solar arrays, which is great because we have a lot of sunlight. But the problem is the heat is so intense, and solar arrays are made out of the same kinds of materials in electronics, and they don't like heat. You might have maybe seen a time when you had your phone in the sun, it got hot and shut off. Well, that's because electronics don't like high temperatures. And so in order to deal with this, engineers created a very intricate cooling system or radiator. And in fact, it was so amazingly developed, it only needed 1 gallon of regular water to cool the solar arrays. And so on the closest approach, they fold in and they are protected from the heat by a combination of the heat shield and the solar arrays cooling system. So how close is the solar probe going to get? Well, here's the sun on a 100-yard line. On one end is the sun, the other end is the Earth. Venus would be at the Earth's 28-yard line, Mercury at the 35. So the solar atmosphere that we're interested in seeing extends out to about the 15-yard line. The Helios 2 spacecraft was up until now the closest spacecraft, reaching the 29-yard line. Now, the Parker Solar Probe is actually going to make it to the 4-yard line, basically within 4%, well within this region of the sun's atmosphere. Now, one of the things I didn't mention is originally we called it the Solar Probe Plus, but the spacecraft was named after Parker, the gentleman who discovered the solar wind. And in fact, this is the first spacecraft to be named after a person who's still alive. And in fact, in August 2018, when we launched the Parker Solar Probe, Eugene Parker, his wife and son were at the launch and were able to see the culmination of all his research over the years as the spacecraft was launched on its voyage to come within roughly 3.5 to 4 million miles from the sun's surface. Here's an animation showing the orbit. So it's launched from the Earth, and each flyby around, it's making 24 orbits. On 7 of those orbits, it flies by Venus, which gives it a kick, a gravitational assist, allowing it to get closer and closer so that it can make its closest approach. Here's a look at its first and last flyby. The first perihelion, its first approach to the sun, has already been made. It's now made 3 of these visits. And you can see where it actually encounters Venus on some of its orbits, 7 of these orbits. So on its first perihelion, as we call it, closest approach to the sun, it's actually just under 36 solar radiuses. And on its final on its closest approach, the minimum perihelion, it's 8.86, just under 9 solar radiuses. And so October 29th in 2018, it made its closest approach, that's 26.5 million miles. And at that point, it was the fastest spacecraft ever, traveling at over 150,000 miles per hour. When it makes its closest approach, which will be in 2024 on a 24th orbit, it'll be traveling approximately 430,000 miles per hour. That's fast enough to go from Philadelphia to Washington, D.C. in 1 second, less than 4 million miles. So one of the amazing things about the timing of the Parker Solar Probe is not only is it the culmination of 60 years of science and 60 years of technology development, but it also corresponds to some other missions and telescopes which are giving us a first unique look at the sun. So over the past many years, scientists have been building, with the support of the National Science Foundation, the Daniel Inouye Solar Telescope in Hawaii. And this is providing unique views, high resolution views of the sun in visible light, allowing us to see the sun's visible surface, the photosphere, with detail never before seen. We can see structures down to the size of what are called granules. These are where solar material bubbles up to the surface, much like a pot of bubbling water. And these bubbles, or granulation cells, are roughly the size of Texas. They're about 4,000 miles across, or 7,000 kilometers roughly. And you can even see structures within them that's about the size of Manhattan, the Manhattan skyline. But in addition, we also were able to launch a new mission with the support of our partners at the European Space Agency, a mission that they built, which NASA launched and provided some instrumentation, called the Solar Orbiter. Now, this mission supplements and complements the work of Parker Solar Probe. While it doesn't travel as close to the sun as Parker Solar Probe, it looks at what's happening after things pass Parker Solar Probe and start traveling out into the inner solar system, but also its orbit is not in the plane of the solar system, but in fact it moves out of the plane of the solar system, roughly 30 degrees of an angle, and this is giving us a first ever view of the poles of the sun, the north and south pole. These are areas where we don't have any data, but we know these areas are very important to understand what drives the sun, the magnetic fields that are driving the sun, and this is giving us the opportunity to really understand the bigger picture of what's happening. So we now have the Daniel Inouye telescope giving us details of the solar disk as the Parker Solar Probe is traveling closer and closer to look very, very close to the sun's surface in the sun's corona, and then having the solar orbiter spacecraft to give us views in the inner solar system as well as views from the pole. Together, these are bringing us into a new age of solar physics that we can finally start to understand why the sun is active, how its magnetic field drives space weather, how it drives solar eruptions, flares, coronal mass ejections, the solar wind, and ultimately to help us understand how those events can be possibly predicted and forecast like weather we have here on Earth, because not only do they give us the beautiful northern and southern lights, but in fact they impact our technology, they impact our ability to communicate, they disrupt our spacecraft, and they can even create a hazardous environment for our astronauts in low Earth orbit, and as they travel to the moon and eventually beyond to Mars. Understanding space weather helps us protect our local infrastructure, our technology, as well as improving our ability to explore our solar system. Thank you very much. You can find out more about Parker Solar Probe at the Johns Hopkins Applied Physics Lab. You can follow NASA on Facebook at NASA Sun Science. Also, my Twitter is @TheSunToday, and NASA Sun is the other Twitter account. And you can find out more about Parker Solar Probe and Solar Orbiter at my own website, thesuntoday.org, or send me an email, c.alex.young@nasa.gov. Thank you, and I hope you enjoy the rest of the NEAF 2020 virtual conference.
Hey everybody, Scott Roberts and
Mike Hatch
here at the Explore Scientific showroom for NEAF, the virtual experience. And we're here to talk a little bit about our 16-inch truss tube Dobsonian.
Oh yeah.
Which is what? It's going to be the
door prize.
The door prize.
The door prize.
Right. And so this is an ultra portable, easy to assemble telescope valued at, what's the normal value on this?
Normal value is $31.99.
And we're gonna be giving a NEAF special on this for $24.99, but you might win it here at this event. I mentioned that this telescope is really easy to assemble. We have a little video here just to kind of show the major assembly of this telescope. When it's all assembled though, the thing that's really cool about it is that it pretty much stays collimated. But the collimation of it's pretty easy to do. And what do you use, Mike?
Yeah, so with the Dobsonian comes with the collimation tool, and it is an easy one-person collimation job. Literally, you can take this tool down there, collimate your primary mirror.
Right.
And you've got some adjustments for your secondary mirror, but other than that, you'll be ready to go.
It's all no tool knobs and stuff.
It
now,
is.
on normal Dobsonians, you're going to be back here making adjustments to the mirror. You might have somebody over here saying, you know, is the laser lined up? Or if you're doing a visual collimation, you know, checking it and adjusting it. But this can be done with one person.
Right.
And that's really unique to this design. So this is a part of a family of telescopes that runs from a 20-inch telescope all the way down to a 10-inch. So we've got 4 models, all available from Explore Scientific and from our dealers here that we'll be highlighting for the NEAF special.
Right.
Anyways, guys, we have a lot more to show you. We're real excited to be here participating in NEAF, the virtual experience, and stay tuned for more.
Ready for a new kind of telescope experience? Unlock the power of your smartphone to help you navigate the night sky. Introducing StarSense Explorer by Celestron. It's fast, easy, and accurate. In minutes, you're ready to take a guided tour of the universe. First, dock your smartphone and launch the StarSense Explorer app. Unlike other astronomy apps, StarSense Explorer aligns precisely with your telescope and uses sky recognition technology to pinpoint its exact position in the night sky. Follow the simple instructions, and in seconds, the app generates a list of all the best objects currently visible in the night sky. Select an object from the list and follow the on-screen arrows to the desired object. As you move the telescope, StarSense Explorer recalibrates its position in real time. The bullseye turns green when your object is ready to view in the eyepiece. It's that simple. StarSense Explorer works anywhere in the world, no cell signal required. So whether you're in your backyard or a remote dark sky location, the universe is yours to explore.
From the time it took Voyager to leave the Earth and reach the edge of the solar system, I went from being a baby to a high schooler to a university graduate to a worker to a business owner, and now I'm a husband, a father, a postgrad student, a science communicator, a musician, a YouTuber, and a backyard astronomer. I've been lucky to reach this point to be able to buy some of the best equipment an amateur astronomer could dream of. But there's one thing I can't afford, and that's time. Astronomy has made me a more patient person, and the constant drive to get better and collect more data to capture the wonder of the cosmos is something I have to balance with everything else in my life. So when I see a telescope with a lower F number, I know that its value to me is far greater than money alone. A telescope's value is not just the sum of its parts. It comes from how much you can get it outside and how much you can get out of it. That's why I jumped to buy the Celestron RO Acumen Schmidt Astrograph 11. Its 620mm focal length at f2 allows me to capture the incredible southern hemisphere nebulae, sometimes within a single night, but always with revealing depth and signal. I've been shooting the universe with the RASA 11 for years now, and it's allowed me not only the satisfaction of sharing these unique views from my end of the world, but also to detect and track asteroids, which is an area I'd love to explore further. The RASA 11 easily crosses that divide between a consumer scope and a scientific research-grade observational telescope for discovery and analysis. The real limit for the RASA 11 is really how far I'm willing to take it, and it's nice to have a telescope that I won't outgrow for a long time, because time is the only thing we don't get more of.
The QHY-294C is an 11.6 megapixel color camera with a highly sensitive, back-illuminated, 4/3 inch 14-bit Sony CMOS sensor. The QHY-294C boasts not only high QE, but also exceptionally low read noise and dark current. The heart of the camera is a Sony IMX294 CMOS sensor. This sensor has incredibly low noise performance and exceptionally high sensitivity due to its quantum efficiency. In a typical front illuminated sensor, photons from the target entering the photosensitive layer of the sensor must first pass through the metal wiring that's embedded just above the photosensitive layer. This wiring structure blocks some of the photons and reduces the efficiency of the sensor. In a back-illuminated sensor, however, the light is allowed to enter the photosensitive surface from the reverse side. In this case, the sensor's embedded wiring structure is below the photosensitive layer. As a result, more photons strike the photosensitive layer and more electrons are generated and captured in a pixel well. This ratio of photon to electron production is called quantum efficiency. The higher the quantum efficiency, the more efficient the sensor is at converting photons to electrons, and hence, the more sensitive it is to capturing an image of something dim. For color cameras, another factor that affects the final quantum efficiency of the sensor is the filter layer. Nevertheless, even taking into account the filter factors, in the case of the 294C camera, the resulting quantum efficiency remains very high, even in the far red and near infrared. At the H-alpha line near 656 nanometers, for example, the QE is still a whopping 70%. This is very high for a color sensor, even for a monochrome sensor. To further boost low light performance while maintaining the most dynamic range possible, the QHY-294C automatically switches from low gain to high gain at the optimum point. At its lowest gain setting, the read noise of the camera is about 6.8 electrons. At unity gain, it's about 1.6 electrons. And at its highest gain, the read noise is remarkably close to just 1 electron. The 294C's sensor has a dual gain mode, HGC, or high gain, and LGC, or low gain. The 294C camera will switch the two modes automatically when the user sets the gain to around 1600, because it is at that point that you get the benefits of the ultra-low read noise of the HGC mode and maintain the full well capacity of around 14,500 electrons at the switch point setting. Using a USB 3.0 high-speed interface, the QHY-294C produces 16.5 high-resolution frames per second. That is a full 11.6 megapixel frame with 14-bit A to D. Higher rates are achieved by selecting a region of interest. For example, the camera will produce 41 frames a second at 1080 lines and nearly 300 frames a second at 100 lines. The QHY-294C has an internal 256 megabyte high-speed DDR3 image buffer. This is more than enough for frame storage, and it significantly reduces any issue of lost frames due to a busy computer CPU or slow USB connection or communication packet errors. The QHY-294C uses QHY's proprietary low dark current control technology. This technology significantly reduces the dark current noise in our CMOS cameras. The 294C has very low dark current as a result, lower than most CCD cameras, allowing for very long exposure times. With the sensor temperature set to -10 degrees C or lower, the dark current is reduced to less than 1/100th of an electron. The 294C camera benefits from more than a decade of cooled camera design experience. QHY CCD has implemented full anti-dew and anti-frost control solutions. Unlike DSLRs, the sensor in a dedicated astronomy camera is often thermoelectrically cooled to low temperatures in a sealed chamber to reduce the noise that otherwise accumulates in exposures of long duration. Dew is moisture that condenses onto the outside surface of the camera's chamber window due to the cooling of the sensor inside the chamber. Frost, on the other hand, is moisture that freezes on contact with the inside of the chamber window when the temperature of the chamber is reduced below 0 degrees. To prevent either of these conditions from interrupting your imaging sessions, the QHY-294C camera has an integrated drying port on the side of the camera accessible by the user from the outside, where a desiccant tube can be attached to eliminate any built-up moisture inside the chamber. A desiccant tube is included with the camera. Additionally, the light shield over the chamber window is equipped with built-in heating elements to keep dew from forming on the outside of the chamber window. The QHY-294C has a short back focus distance, allowing the use of QHY's 0.5 millimeter to 27 millimeter spacers in step sizes of 0.5 millimeter. Finally, the QHY-294C is supported by drivers and software for multiple platforms. Both QHY and ASCOM drivers are available at the QHY CCD website, and EasyCap software is available for free for Windows, Mac, and Linux operating systems. The suggested retail price of the QHY-294C camera is $999.
Hello, my name is Simon. I am the Stupid Astronomer, and because I do the stupid things so you don't have to, and today we are going to have a look at Starlight Express, not to be confused with Starlight Instruments, who make fantastic focusers and collimators. No, we're talking Starlight Express, the guys who make cameras. So this particular one that we're going to be looking at is the Trius SX694 Pro. Bit of a mouthful. This is the actual kit version. It has the camera, the filter wheel, and every other cable you can possibly imagine. Of course, they sell all their cameras individually. You can buy the Lodestar X2 by itself or just the camera by itself, depending on what it is that you need to do. But let's go into a little bit more in-depth about what comes inside of this kit, because that's probably what you're more interested in, I hope. Needless to say, here's the camera. You've got to understand, CCD is not dead. Contrary to belief, On Semi, the company that makes a large majority of these CCD cameras, are obviously no longer manufacturing them, but it doesn't mean that there are no more cameras left or no more CCDs left. In fact, the 694 is actually made by Sony. Strangely enough, Sony actually makes a lot of the sensors by today's standard. I'm not going to go into this comparison about CCD versus CMOS, because that's like a whole argument on itself and a whole video on its own right there. But let's have a look at these Starlight Express cameras. The build quality behind these are exceptionally good, and they're actually manufactured in England of all places. More importantly is the camera itself. Compared to something like a CMOS camera, yes, it is not as high resolution, but the big difference here is they are way more sensitive when compared to something like a CMOS camera. Now, in this kit, you will also get their mini filter wheel, which also has the off-axis guider built into it. And if you're wondering what this guy here is sticking out, this is the Lodestar X2, which is a guide camera. In fact, Starlight Express probably makes one of the best guide cameras out there. Probably the Ultrastar may be the better of the two, but the Lodestar X2 is probably one of the most popular ones around on the market today. It's also based off of CCD technology, giving it that superior sensitivity compared to other CMOS cameras. So my name is Simon, I am the Stupid Astronomer. If you want more information about these products or any of the other Starlight Instrument products, feel free to give us a call. The number is 888-427-8766. And of course, you can check out our website, which is telescopes.net, and I will see you again.
Hello everybody, Dan Higgins again for Camera Concepts and Telescope Solutions in Stony Brook, New York, and thank you again for visiting us at NEAF, the virtual experience. So what's our next sale? Is solar your thing? Well, if solar's your thing, we got a solar sale for you. It's the Coronado PST sale. Right now, the 1.0 Coronado PST, the regular model, normally $699, is now $549. That's $150 off. After that, you want a little bit more detail? We have the 0.5 angstrom, the half angstrom model. Okay, normally $11.99, now it's $8.99, $300 off. After that, if you want another little lightweight mount to kind of put your brand new PST on it, we got the AZS mount, normally $90, now it's $62, $28 off. So come on down to cameraconcepts.com. If you don't have a web browser, phone number's over there. Give us a call at the store. Visit us on our website. Get your NEAF deals today for the AZS, the Coronado 1.0, or the Coronado 0.5. So thank you. We'll see you at cameraconcepts.com, and keep on watching.
And then on to our filter wheels. We have 3 main filter wheels now. We still have the original standard filter wheel, USB filter wheel that we started producing around about 10 years ago. We have 3 now which have the built-in off-axis guider, which is a really, really important part of an imaging system. To start with, we have the little mini filter wheel here. So this is both powered and driven through the USB. It has a small pick-off prism with a C-mount top here, ideal for your lodestar just to sit on, so that screws directly on here, as you can see with these other 2 here. This is a 5-position wheel. It has 1¼ inch filters. We also do a 36mm unmounted version as well, but the standard 1¼ inch version is the most common. They have T-thread both on the front and back. The main advantage with this one and also our new MIDI filter wheel is that when you accompany it with one of our cameras, or a camera with about 17mm of back focus, the total back focus of the complete system here, so the filter wheel and the camera, is 55mm. So it's been specifically designed to hit that sweet spot for most refractors and their focal reducers and their field flatteners as well. So if you have a refractor or even an SCT with a limited back focus, but require a filter wheel with an off-axis guider built in, then this is exactly what you're looking for. So we then go over to the new, this is a new one that we were going to be releasing at NEAF. This is a MIDI filter wheel, so this is going to still, we're still selling this standard filter wheel, but this is going to gradually replace with people that want to do imaging with an off-axis guider as well. It's 7-position 1¼ inch filter wheel. We also do 5-position with 2-inch and also 36mm, and we also do a 50mm unmounted version as well. So this again has the 55mm back focus with one of our cameras, and obviously the Lodestar or even the Ultrastar will fit directly on top. Once again, it's powered through USB and driven through USB. This one also has an option for a serial port if you wanted to go old school and use the serial port instead. And then we come to the big wheel. Now this is obviously a fairly big piece of hardware. Weighs about a couple of pounds, just 2 or 3 pounds. Exactly the same sort of setup. This one's a little bit thicker, unfortunately. It's around about, with one of the cameras, is around about 57-58mm of back focus. So we're still very close to that sweet spot for the refractors, but not quite there, unfortunately. This one is ideally for something this sort of size, so we're looking at large format sensors. We do a 50mm unmounted 9-position. We also do a 7-position square unmounted filter, which is the 50mm square filters. We do, if you're really ambitious and want lots and lots of filters, we do actually have an 11-position 1¼ inch carousel that will go in this as well. Once again, all powered and driven through the USB, so no external power required. And obviously the Lodestar or Ultrastar can just sit on top of there as well. As I say, we also have an active optics unit. We also have a spectrograph. So realistically, we can accomplish pretty much all of your imaging requirements for your telescope setup. So I just want to say thank you very much for listening to this short presentation. Please follow us on our Facebook page, which is Starlight Express. We also have a customer gallery there, so if you are a customer and you want to show off all your fantastic images, then please join our customer gallery and start posting away on there. We have a website, sxccd.com, so for further information please go on there, and we look forward to seeing you hopefully in September at the real NEAF.
5, 4, 3, 2, 1, 0.
Hi everyone, Dan Higgins at Camera Concepts, and again, thank you. I know you've been hearing me say it all day, but thank you so much for watching and being a part of NEAF, the virtual experience. Got our next set of deals for you, Optolong. We got Optolong filters at 10% off. So 10% off on all Optolong, whether that be the L Pro, the L Enhance, broadband, narrowband, CLS, CLS CCD, whatever you want. We got them all, 2-inch, 1 1/4, 36mm, mounted, unmounted, whatever you want. We got them. So come on down to cameraconcepts.com. Come to our phone number if you want to give us a call at 631-475-1118. Optolong, all filters, 10% off. Can't get any easier than that. Again, cameraconcepts.com, or give us a call at the phone number below. Thank you for watching. Thank you for joining us for NEAF, the virtual experience. Have a great rest of your day and keep on watching the show.
Hey everybody, Scott Roberts and Mike Hatch here at the Explore Scientific Showroom, and we're celebrating NEAF, the virtual experience with you. Right now we've got the IXOS 100 equatorial tracking mount. What can you tell us, Mike?
So this is our lightweight portable equatorial tracking mount. It's designed for small telescopes and DSLR cameras.
Like we got up here.
Just like we've got
Now is this going to come with it, or?
The camera will not come
with it, folks. Okay, all right. But it's mounted on this really cool rail. Okay, so this is part of the system. The rail has a protective stainless steel barrier here that keeps the rail nice and long-lasting.
Right.
It's got 3 spots on it where you can mount the camera. You'll notice it also has threaded holder for European mount cameras because they're a little bit bigger, and then underneath it is the 1/4-20 that everybody's familiar with in the United States. So it can work with cameras all over the world. In fact, works all over the world in northern and southern hemisphere, and it slews really quiet. Why don't you show them?
It does, doesn't it?
That's right. So this is not only a go-to mount, but it's a wireless or wired go-to mount, the same as all the rest of the PMC8 series.
Right.
So it could run off of ASCOM, you could run it remotely if you wanted to. The system also has the ability to auto-guide. This is probably the only, or one of the only equatorial trackers out there for DSLRs with an auto-guiding capability. So you could stick another rail up here and put on a little scope for auto-guiding, and you'll have precision pinpoint stars.
That's great.
Yeah. Anyways, we've got a lot more to show you. But before we go, what's the price on this and the NEAF deal?
So for this whole package, camera not included, it was originally $699, but for NEAF, it is going to be at a special price of $599.
That's a super deal, and only available through Explore Scientific and its dealers. Well, we got a lot more to show you, so stay tuned.
New Mexico Sky's Astronomy Enclave. At 7,200 feet above sea level, you're on top of the world. Nestled among the tall, cool pines of the Sacramento Mountains, we're located in south central New Mexico. Founded in 2004, this premier mountaintop astronomy community offers you the opportunity to make your dreams come true with both mountaintop and mountainside lots. Just imagine living here under some of the darkest and best skies North America has to offer. You'll love the changing seasons, accompanied by our vivid fall colors. As you can see, your new lot is ready and waiting for you. We invite you to come and experience your new home and observatory site, along with all that New Mexico Sky's Astronomy Enclave has to offer. Be it one of our mountainside lots or mountaintop lots, your toughest decision will be in choosing the one you'll call home. Our exceptionally clear skies will provide you with the best images. And yes, you can see your shadow from the summer Milky Way. New Mexico offers some of the most beautiful scenic landscapes, from our national parks to flora and fauna and our wildlife reserves. From our state bird, the roadrunner, and his friend the coyote, to our spectacular fall colors, our world-renowned balloon festival, you'll find our gorgeous sunrises and our spectacular sunsets. New Mexico has something to offer for everyone. Still not a believer? Then feast your eyes on these images that were taken from our mountain. Thanks to our mountaintop location, we have a microclimate. We expect over 300 sunny days and clear nights per year, while less than 20 minutes down the road at Cloudcroft, the conditions are less than ideal. This image was taken from Tom and Marla's home. Take a look at this mountainside lot, owned by Eric and Josephine. As you can see, the layout and design of your new home is limited only by your imagination. From the land of enchantment.
Seeing is really believing, and so my hope is that after someone has heard what we have to say about the Astronomy Enclave, don't take our word for it. Come and see it. Come and really take a look at what this enclave has. Look at our community and understand what our community has to offer, and really look at the skies, because ultimately, if you're doing astrophotography, the skies are the most important.
We're not for everyone, only for those who are looking for the best.
about the moon hat? What is?
So the moon hat is a
You have
hat.
to speak up a little bit.
So the moon hat is no ordinary hat.
Okay, that's why I came over to ask you.
It looks like a warm
knit cap,
fleece hat, but it's actually a scientific moon finding instrument.
Oh, really?
Yep. Forbes magazine called it the best science gift of 2018. We're in 30 science museums around the country.
Okay.
And the reason why they think it's so special is that it creates a model of the moon's orbit as it relates to the phase of the moon.
Okay, for every day?
For every main
phase, okay.
Every named phase, yep. So if you wear it with the new moon in front and you face the sun, which is in the south, you've created a map of the positions in the sky where the moon phases occur.
Okay.
So the new moon is literally in the sky next to the sun. We can't see it, it's too bright, it's a dark side that we're looking at. But a couple days later, we're going to get the crescent moon. If I face the sun, the crescent moon image points to the eastern part of the sky where the moon has moved. A couple days later, we get the seven-day quarter phase, and we see half of the moon. Again, any time of day, I can face the sun, and it tells me where the moon is in the sky. So for instance, he's looking at the sunset. The new moon, the quarter moon, is now at the meridian. Every phase corresponds. The hat will never let you down because it has an instruction manual sewn inside. It's the first hat with an instruction manual. Shows you the names of the moon phases and when they occur, and also the step-by-step moon finding instructions. Yes, Instagram the moon hat.
At Moon Hat?
At the Moon Hat.
At the Moon Hat.
Yep.
Okay.
At the Moon Hat.
It's not up here though. You should have that on there so when people take pictures, they
Yes.
can see it. Oh, the moonhat.com.
Themoonhat.com. You can get to there from there. You can also do my hashtags, which are do science every day. Remember to be curious. Go outside. Look up.
Okay. Oh, it's nice meeting you.
Thanks.
Hi everyone, Dan Higgins again at Camera Concepts in Stony Brook, New York. Thank you so much again for visiting us at NEAF the Virtual Experience. We have our next Camera Concepts exclusive, the Arcturus Binoviewer sale. First time ever on sale right now for $169.95. Well, what does this offer you that other places don't? First of all, the Barlows that it comes with is at 1.85 and 3.0, so it comes with two sets of Barlows. Awesome. So you got nice two different sets of magnification there. There's no set screws with the eyepiece. They're held by the brass compression rings, which is self-centered to keep the eyepieces in good collimation, which is really important, especially when you're dealing with, two eyes. You want to make sure that everything is good. It also comes with an individual diopter for each eye. So some of us, like myself, one eye is a little bit out of whack than the other one. You could change the focus on both of them. So it's really, really good deal at $169.95. The Arcturus Binoviewer first ever sale. Come on down to cameraconcepts.com. Give us a call at 631-475-1118 and we'll take care of you. We'll get you hooked up with those nice 3D views that the Binoviewers gives you. So again, cameraconcepts.com, 631-475-1118. And thank you for watching and enjoy the rest of the show.
Telescope Live is the new platform for amateur and professional astronomers, offering remote access to a global network of telescopes and providing unique features for experienced astrophotographers and people who are just getting started. Our web application is the most innovative platform for astrophotography. With features such as automated scheduling, image calibration, and a dynamic image archive, Telescope Live makes remote observing easier than ever. Through an easy-to-use interface, you can observe galaxies, nebulae, and stars using our wide range of telescopes from the comfort of your home, from any mobile or desktop browser. For everybody who is less familiar with remote imaging, astrophotography, and image processing, Telescope Live offers a wide range of video tutorials and masterclasses created by world leader astrophotographers. On top of our on-demand remote imaging offering, we've just launched Community Observations, consisting in images regularly obtained by our experienced staff and available at a fraction of the acquisition cost. Through our dedicated blog, you have the opportunity to learn more about the current trends in astronomy, with new articles being published every week. You can also share your stunning astrophotography pictures with our growing community and discuss your experiences with fellow amateur astronomers and expand your knowledge of the night sky. Unleash your curiosity with Telescope Live. Sign up at telescope.live for free and start observing now.
Since 2007, Astronomy Technology Today has been the definitive global resource covering the amateur astronomy products industry. Offered in a digital format, the magazine is the ultimate equipment guide for astronomy enthusiasts, providing an unparalleled, in-depth insider's look at today's industry, products, and trends. Page after page of new product announcements, industry news, featured articles, product reviews, and insightful editorials give our readers timely access to information unavailable from any other publication. Astronomy Technology Today and those who contribute to it have a passion for astronomy technology, and we think that shows with the pages of this magazine. And as a subscriber, you'll have access to every issue since 2007 at no additional charge, providing access to hundreds and hundreds of equipment reviews and more. In the end, our goal is simple: providing technical advice, how-to tutorials, showcasing new advances in equipment, and ultimately providing the most trusted international outlet for all things related to astronomy technology.
Hello everybody, Dan Higgins again for Camera Concepts and Telescope Solutions in Stony Brook, New York, and thank you again for visiting us at NEAF, the virtual experience. So what's our next sale? Is solar your thing? Well, if solar's your thing, we got a solar sale for you. It's the Coronado PST sale. Right now, the 1.0 Coronado PST, the regular model, normally $699, is now $549. That's $150 off. After that, you want a little bit more detail? We have the 0.5 angstrom, the half angstrom model. Okay? Normally $1199, now it's $899, $300 off. After that, if you want another little lightweight mount to kind of put your brand new PST on it, we got the AZS mount, normally $90, now it's $62, $28 off. So come on down to cameraconcepts.com. If you don't have a web browser, phone number's over there. Give us a call at the store. Visit us on our website. Get your NEAF deals today for the AZS, the Coronado 1.0, or the Coronado 0.5. So thank you. We'll see you at cameraconcepts.com, and keep on watching.
Hello everyone, Kevin here from Skywatcher, and welcome to our virtual NEAF experience for 2020. Today we're going to be taking a look at all of our brand new products, and if you want to know more on these products, you can always join us every Friday morning at the Skywatcher USA YouTube channel for our What's Up webcast from 10 a.m. to 11 a.m. Pacific time. Now without further ado, let's get started and see what's new for Skywatcher this year. The EQ8R series is our new high-capacity mount. It features 110-pound payload capacity, 8-inch diameter gears, and is excellent for telescopes up to 16-inch in diameter or a wide variety of other heavy tubes. This is literally the ultimate imaging mount for the Skywatcher lineup. The EQ8R builds across the original EQ8 and adds new features for the advanced imager. This includes a cable management system featuring 4 USB 3.0 ports, 3 2.1mm power ports, and 3 auxiliary serial cable ports on the back of the mount. This eliminates cable drag and is perfect for remote imaging. It also has onboard homing sensors and a built-in USB to improve connection to the PC without the need of the SynScan controller. To advance the series even more, we have the EQ8RH model. The RH has a built-in Renshaw incremental encoder built in onto the right ascension axis. At 11.8 million ticks, the encoder keeps precise measurements of where the right ascension is currently positioned. This allows for extremely accurate tracking on long focal length and research systems. The EQ8R series can be sold in 2 different configurations, the mount head and the mount head with a tripod. These also include 2 22-pound counterweights. Skywatcher has also updated 2 of our most popular product lines for 2020. The new EQ6R features our brand new updated motor board, which has a built-in USB, which it offers direct connection to a PC computer without the need of the SynScan hand controller. Our next update is our FlexTube SynScan Dobsonians now have built-in Wi-Fi. This allows you to control the telescope with your iOS or Android device and works on our 8, 10, 12, 14, and 16-inch Dobsonians. For 2020, Skywatcher is proud to announce a series of new products to our lineup as well. To begin with those, let's introduce the Solar Quest. The Solar Quest is the ultimate solar mount for those interested in the sun, including eclipse chasers. It has a built-in system called HelioFind, which actually locates and aligns automatically onto the sun. It can do this with built-in GPS and auto-leveling technology. The mount can be powered by 12-volt with an included adapter plate, or 8 AA batteries. It features an 11-pound payload capacity, so you can use it with your favorite solar equipment, and includes everything you need to get started, including the mount head, 8-inch pier extension, aluminum tripod, and an accessory tray. The next new addition is our AZ-EQ6. The AZ-EQ6 can be used in Altaz or equatorial configurations, features dual DV saddles as well as a secondary saddle plate that can be attached to the counterweight bar for use of side-by-side telescope setups. The mount features a 44-pound payload capacity per side, which can be extremely effective in dual mode, as well as Freedom Find encoders, which allow you to move the mount around manually without losing your alignment. It also includes a 2-inch rolled steel tripod and 2 11-pound counterweights. Lastly is the new addition for Skywatcher, and that is the EvoLux ED series. This is a new refractor series that's going to sit between our Evo Stars and our Esprits. The EvoLux are new, faster ED double optics coming in 62 and 82 millimeter apertures to start. These feature a matched doublet with a synthetic fluorite rear element and are fully multi-coated. The mechanics of the EvoLux series are also upgraded with a retractable dew shield, clamshell with Vixen-style dovetail plate, 2.4-inch dual-speed rack and pinion focusers with a compression ring, and a finder bracket on the clamshell. Well, that's it for our 2020 NEAF virtual experience. If you want to know more about these products, you can check us out at skywatcherusa.com or join us on April 10th on our What's Up webcast on YouTube and see a full in-depth overview of all of our new products. We hope to see you soon, and clear skies.
Hey guys, Mike Hatch and Scott Roberts here with Explore Scientific in the Explore Scientific showroom. And we are in front of our First Light series telescopes. Yep. Now, Scott, can you tell us a little bit about these?
Well, you know, the First Light, I named them First Light because for many people, they would experience First Light with a telescope. First Light really does mean the first time a telescope sees starlight. So I thought it was a great and fitting name for this series of telescopes. They are inexpensively priced, okay? But they do include some very nice hardware on them. Some of them have 2-speed focusers, some of them, and there's a lot more than what we're showing here. We've got a refractor, Newtonians, reflectors, and we've got Maxitov reflectors as well, in different apertures, something that would work for everybody. Behind all that, which you really can't see right now, are some Dobsonians, which we have in the line as well. What's the deal that we have on First Light series? Because there's so many of them to choose from.
There are so many to choose from. So for NEAF, we're going to have our First Light series, each model on all mounts, 20% off.
That's a great deal. You'll save big bucks, and you'll be able to get back out under the skies when all this clears over and have a great time with your First Light series telescope. We've got more to show.
Hi everyone, Dan Higgins here from Camera Concepts and Telescope Solutions in Stony Brook, New York, and thank you again for joining us for NEAF, the virtual experience. So here we go. Our next set of deals is Celestron. So Celestron, what we have for you is the C-Gem 2 mount at $150 off. Well, what is a C-Gem mount good for? Well, it starts off with a 40-pound payload capacity, which is good for pretty much if you're just starting off with astrophotography, or if you're doing some heavy-duty visual. It's also got a latitude range of 15 degrees to 70 degrees. So pretty much anywhere you are, it's going to be good for what you need. It's also got a nice 2.0 port USB at the bottom of the hand controller, so you can connect it to your computer through your ASCOM drivers. Don't forget the ASCOM drivers. You're going to need them. You astrophotographers out there, you know what I'm talking about. Also, it's got a dual fit dovetail saddle. So whether you got the V-style dovetail or the D-style dovetail, you're good to go. It's also got a trainable periodic error correction, which is really good when you got those little minute issues with tracking and your gears are a little bit off. It's trainable, so you can fix that. So Celestron, $150 off the C-Gem 2 mount. Come to cameraconcepts.com. Here's our phone number. There's our website. Thank you so much. Come on down. Thank you for joining us for NEAF, the virtual experience. And don't forget, Celestron, C-Gem 2 mount, $150 off. Thank you so much.
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be, and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
It's great to be here. Thank you. Wow, there are a lot of you. What a great conference.
Friday, I was promoted chief engineer, and that means that I'm really busy with the mission.
No one has ever seen before.
Hello again. Our next speaker is the chair of the Yerkes Future Foundation. Her involvement with Yerkes started in April 2018 when the University of Chicago indicated they were closing the observatory. The observatory, often referred to as the birthplace of modern astrophysics, was founded in 1897 by astronomer George Ellery Hale. Please welcome to NEAF, the virtual experience, Diana Coleman.
Hi, I'm Diana Coleman, and I would like to say thank you to NEAF and all of the people who have been involved in putting this program together. We very much appreciate the opportunity to talk to you about Yerkes Observatory and about the Yerkes Future Foundation. We also hope that all of you are staying safe and healthy. We know that it's a very difficult time right now, and we want you to understand that we have a lot of concern about all of the people who are involved throughout the world, but most especially in your New England area and again in Wisconsin. The Yerkes Future Foundation was set up about 2 years ago, and I have had the privilege of serving as its chair for that length of time. We know that many of you have been out to Yerkes Observatory, and we truly appreciate your support over this past 2-year period. But we also know that some of you haven't had that opportunity, so we decided that we would bring Yerkes Observatory to you. And so now we're going on a road trip. We've been fortunate over the past 2 years to have a number of people volunteer their help. One of those individuals is a young man named Ryan Bensheimer, who has a company called Ideal Impressions. Ideal Impressions generally does wedding photography, but Ryan put together a short film so that you can see the beauty of the area. Yerkes Observatory sits on Geneva Lake in Williams Bay, Wisconsin. It's an iconic building that dates back to the late 1800s. Many pictures have been done, paintings, and of course this is the entry of the foyer. It's a beautiful building leading to the giant refracting telescope, the world's largest. There are several areas throughout the observatory, libraries. That's an old photo of the telescope with Albert Einstein. And it's beautiful no matter what season of the year. As you can see, a lot of people have loved the observatory, especially in the fall. And it brings a great deal of joy, no matter how old you are. That's a little road trip for you, and we certainly hope when everything has transpired that you will be able to come out and actually see Yerkes Observatory for yourself. It is much loved. And certainly, for today, what I'd like to do is take you through what's been going on of modern astrophysics in the United States, but most particularly what's been happening recently. We are going to go through the ownership and approval process. We've been fortunate over the past 2 years building needs a number of people, because there are some needs, volunteer their help. 123-year-old one of those individuals is a young man named Ryan Bensheimer, who has a company called Ideal Impressions. The staffing needs that we have, which I'm sure some of you are very interested in, generally and of course wedding campaign needs. But Ryan put together a short film so that you can see the beauty of the area. We finally set up our website and our email address. Yerkes Observatory sits on right now Geneva Lake. We are looking at in Williams Bay, Wisconsin, being completed on May 1st. It's an iconic building. At that point in time, that dates back to the late 1800s. Will transfer 49 acres of property. And many pictures have been done as well. At the giant refracting the 49 acres, the world's largest, will allow us to provide. There are several areas throughout the observatory around the observatory building, as well an old photo of the restore some of telescope with Albert Einstein. Beautiful Olmsted landscape design that and was in beautiful place no matter what season of the year. We have a committee that's working on that right now, and that includes a lot of the garden club from around the area. And we have, as you can see, a lot of people have loved the observatory as well, to make sure that we're following, especially in the best practices, and making sure that it's applicable to the situation as it occurs now. The historic items that are in the building, a great deal of joy, include, no matter how old you are, the giant refracting telescope. But there are smaller telescopes, the glass plates that are currently in very safe storage. That's a little road trip for you at the observatory. And we certainly hope a number when of everything other has transpired throughout the building that you will be able to come out. One of the and actually see your running observatory for yourself is that with the coronavirus issues, the village of Williams Bay has not been able to hold all of their plan commission of modern astrophysics. So as a result, some of our permitting has been delayed. That has actually worked to our advantage. We've been fortunate over the past 2 years to have a number of people in that we don't have to volunteer their help work on the parking area that we thought we were going to individuals have to do is a young man named Ryan Bensheimer, who has obviously a company called Ideal Impressions. Cash outlays. Ideal Impressions. One of the other things, though, that we generally does sure wedding photography. in this but process. Ryan put of together public a meetings short film is so that you can see the beauty of the area, citizens in the area who dearly love the observatory. Yerkes Observatory sits on scientists and educators Geneva Lake around the world in Williams Bay, Wisconsin, who have been very interested in making sure it's an iconic building that dates back to the late 1800s is well taken care of and positioned for the future. You might expect there are some needs for the observatory. We need to improve the dome that houses the giant refracting telescope. The brickwork around the base needs to be remortised and then sealed in an appropriate manner to make sure that no water seeps in the way that snow accumulates on the exterior. We don't want to have it damage the brickwork on the interior. At the same time that we're doing the exterior brickwork, we're also going to be doing interior brickwork and removing some of the paint that was there and resurfacing that entire interior of the dome. The other thing, which is probably more exciting, is that we're going to be working with a gentleman named Ralph Nye from Lowell Observatory in Flagstaff, Arizona. Ralph was gracious enough to come up a couple of months ago and take a look at the giant refracting telescope to make sure that we could appropriately protect it while the brickwork was being done, but also to make sure that we could refurbish it in a way that brought it back to its glory of being a really spectacular looking telescope. Ralph has been very gracious about this entire adventure, and he will be working with a gentleman named Ed Struble. Ed Struble has been at Yerkes Observatory for almost 30 years, and he knows everything about the observatory and the telescope that there is to know. The other thing that we're going to be doing is working through the building room by room to make sure each room is clean, appropriately furnished, taken care of, painted where necessary, and then also have the floors, which are beautiful walnut floors, refinished. So there's going to be a lot of lighting, redone, paint, and furniture. And the 1970s era lighting is leaving and being replaced with appropriately historic, styled, but LED lights. So I think that that's going to overall be a much better look for the observatory in the long run. When we start talking about what's going to be happening with Yerkes Observatory in the future, we have a lot of ideas. And we've also been fortunate that we've had two wonderful consultants working with us, Ian McLennan and Bill Peters. What they have started to do is help us put together a preliminary strategic master plan. And this master plan will have several phases. We're right now in the early phase, which obviously focuses on the building improvements, refurbishing the telescope, hiring staff, laying the groundwork for all of the fundraising. But also it involves going out and getting greater community involvement, greater research in terms of what we want to accomplish. So it's not only talking with the people in Williams Bay and the greater Geneva Lake area, but also talking with a lot of you, talking about the educational programs, collaborative work that could be done, and all of the ideas that you've put forth to us over the past year and a half. We've been so grateful for some of the input from people such as John Briggs, who did an incredible job looking at the inventory and especially giving us detailed information about what was in place at the observatory. The other thing that we'd like to do is establish Yerkes Observatory as a destination. Not only a destination for people just to come in and see what has happened over the years and all of the ideas, the great people who have been there and the discoveries that were made there, but also a destination for educators and scientists, astronomers who want to come in and work together to look at various projects and ideas that don't necessarily involve the Great Refractor, but could involve other smaller telescopes, or just to do theoretic research. Bring in your graduate students from colleges and universities throughout the country, most especially in the Midwest, and look at all of the things that can take place there. One of the other parts of the strategic plan, obviously, is to look at governance, how we will work through the operational aspects of Yerkes Observatory, not only just the maintenance of the building and all of the artifacts that are inside, but looking at all of the things that are involved in making this come alive again. We also need to set up a staffing structure for the administration of the observatory and all of its programs. Additionally, within this preliminary strategic master plan, we're looking at capital costs and timelines, because there again, we need to make sure we take a very measured approach on how we look forward to the first phase, and then ultimately all of the additional things that we would like to see happen there. We think of phase one basically as being now through 2024. One of the things that has to take place fairly quickly is establishing a staff for the observatory. So let's talk about the type of individuals that we're looking for. But rather than go into great detail, what I would like for you to do is also to take a look at our website, and I will give you that information a little later on. When we look at Yerkes Observatory, we know we need an executive director who would report to the Yerkes Future Foundation Board. Additionally, we want a director of buildings and grounds, and that person we already have in place, and that is Ed Struble. As I mentioned before, he's been with Yerkes Observatory for almost 30 years, and I don't think we could move forward without him. Some of you have been fortunate in that you know who Ed is, and I think you'll agree that this is a very wise decision on our part. We're also looking at this point for a part-time administrative assistant, and that individual would be responsible for scheduling and working with the executive director and with Ed Struble. As we move forward and we begin to expand, we're going to need a development director. That person should have some extensive fundraising experience, but also should be part of our community, should be a person who can go out and talk to people and work with them, and also work very closely with the executive director. And finally, and certainly a key piece in all of this, is we will need an education director. And that job has yet to be completely defined. So what I'm hoping is, as we work through and start posting some of these positions on our website, that those of you who are interested will contact us. Expect this is not going to be inexpensive. We know that we have a lot of work to do, both in terms of taking care of the building and the landscape, but also in terms of providing educational programming and working with other educators and universities and colleges. So we're looking at two pieces. First of all, there's a long-term funding need of about $20 million. That will generate income in order to help offset some of the operating costs of the observatory itself. The immediate needs, however, are probably about $5 million, and that will cover some of the repair work and also start laying the groundwork for our staffing, as well as for some educational programming. If you look at our base structure for preserving, protecting, enhancing, and expanding Yerkes Observatory, both in terms of preserving and protecting the building, but also in enhancing all of the activities that are at the observatory itself, we're going to need about $5 million. This is an iconic, historic, amazing building. And I've often thought it just dropped out of the sky and landed in this little tiny village. But it has been the home to so many amazing scientists, astrophysicists, educators, that it is a valuable piece of the American history, and also a valuable piece of modern astrophysics in the United States. What we would like to do as a foundation is use the funding that we receive in support of Yerkes Observatory to further that and make sure that the history that is so rich right now gets to last for another 123 years. So, to wrap everything up for you, this is an adventure, but it's an adventure for all of us. And we sincerely hope that you will keep in contact with the Yerkes Future Foundation as we try and bring Yerkes Observatory back to life again. On your screen, you should see the YerkesFutureFoundation.org. That is our new website. If you need to email us, please feel free to do info@YerkesFutureFoundation.org, and we will respond. I would also like to take this moment to thank everyone on the Yerkes Future Foundation Committee, everyone at NEAF, and also Scott Roberts, who took a lot of time to make sure that we could pull all of this information together. I met Scott about a year and a half ago, and over the course of this past time frame, he has been very gracious in making sure that all of the contacts that we could possibly need have been available to us. Additionally, I'd like to thank all of the faculty in the sciences and astrophysics, astronomy at the University of Chicago, and the archivists and librarians. They have been remarkable in terms of providing support and information to us. John Briggs, of course, has been a godsend in terms of doing inventory and all of the work that he did for so many months. Finally, I would like to thank all of you. I would have loved to have been there with you in person. I will try and be there in September so we can have an extended discussion about this. But please know that when Yerkes is up and running again, you are all welcome, and I would love to meet every single one of you. Have a wonderful day and have a wonderful summer. We will be looking forward to meeting you in the future. Thank you.
Hey everybody, Scott Roberts and
Mike Hatch
here at the Explore Scientific showroom for NEAF, the virtual experience. And we're here to talk a little bit about our 16-inch truss tube Dobsonian.
Oh yeah.
Which is what? It's going to be the
door prize.
The door prize.
The door prize.
Right. And so this is an ultra portable, easy to assemble telescope valued at, what's the normal value on this?
Normal value is $31.99.
And we're gonna be giving a NEAF special on this for $24.99, but you might win it here at this event. I mentioned that this telescope is really easy to assemble. We have a little video here just to kind of show the major assembly of this telescope. When it's all assembled though, the thing that's really cool about it is that it pretty much stays collimated. But the collimation of it's pretty easy to do. And what do you use, Mike?
Yeah, so with the Dobsonian comes with the collimation tool, and it is an easy one-person collimation job. Literally, you can take this tool down there, collimate your primary mirror.
Right.
And you've got some adjustments for your secondary mirror, but other than that, you'll be ready to go.
It's all no tool knobs and stuff. Now,
is.
on normal Dobsonians, you're going to be back here making adjustments to the mirror. You might have somebody over here saying, is the laser lined up, or if you're doing a visual collimation, checking it and adjusting it. But this can be done with one person.
Right.
And that's really unique to this design. So this is a part of a family of telescopes that runs from a 20-inch telescope all the way down to a 10-inch. So we've got 4 models, all available from Explore Scientific and from our dealers here that we'll be highlighting for the NEAF special.
Right.
Anyways, guys, we have a lot more to show you. We're real excited to be here participating in NEAF, the virtual experience, and stay tuned for more.
Ready for a new kind of telescope experience? Unlock the power of your smartphone to help you navigate the night sky. Introducing StarSense Explorer by Celestron. It's fast, easy, and accurate. In minutes, you're ready to take a guided tour of the universe. First, dock your smartphone and launch the StarSense Explorer app. Unlike other astronomy apps, StarSense Explorer aligns precisely with your telescope and uses sky recognition technology to pinpoint its exact position in the night sky. Follow the simple instructions, and in seconds, the app generates a list of all the best objects currently visible in the night sky. Select an object from the list and follow the on-screen arrows to the desired object. As you move the telescope, StarSense Explorer recalibrates its position in real time. The bullseye turns green when your object is ready to view in the eyepiece. It's that simple. StarSense Explorer works anywhere in the world, no cell signal required. So whether you're in your backyard or a remote dark sky location, the universe is yours to explore.
From the time it took Voyager to leave the Earth and reach the edge of the solar system, I went from being a baby to a high schooler to a university graduate to a worker to a business owner, and now I'm a husband, a father, a postgrad student, a science communicator, a musician, a YouTuber, and a backyard astronomer. I've been lucky to reach this point to be able to buy some of the best equipment an amateur astronomer could dream of. But there's one thing I can't afford, and that's time. Astronomy has made me a more patient person, and the constant drive to get better and collect more data to capture the wonder of the cosmos is something I have to balance with everything else in my life. So when I see a telescope with a lower F number, I know that its value to me is far greater than money alone. A telescope's value is not just the sum of its parts. It comes from how much you can get it outside and how much you can get out of it. That's why I jumped to buy the Celestron RO Acumen Schmidt Astrograph 11. Its 620mm focal length at f2 allows me to capture the incredible southern hemisphere nebulae, sometimes within a single night, but always with revealing depth and signal. I've been shooting the universe with the RASA 11 for years now, and it's allowed me not only the satisfaction of sharing these unique views from my end of the world, but also to detect and track asteroids, which is an area I'd love to explore further. The RASA 11 easily crosses that divide between a consumer scope and a scientific research-grade observational telescope for discovery and analysis. The real limit for the RASA 11 is really how far I'm willing to take it, and it's nice to have a telescope that I won't outgrow for a long time, because time is the only thing we don't get more of.
Ladies and gentlemen, this is Daniel Mounsey, aka Dr. D, and we're back again with a Starlight Instruments candy table. And we have some beautiful accessories here. Most telescopes come with their own standard focusers, but Starlight Instruments is the standard of excellence that most people gravitate to when they want to take it up a notch, particularly with astroimaging where you're having heavy payloads with cameras and filter wheels, etc. And we have an example here on a beautiful Explore Scientific Essential 127 ED, and this has got a carbon fiber tube. So Starlight Instruments makes all of the attachments and adapters. They even have a flow sheet on their website that explains what adapters and focusers are compatible with each one, which is a nice feature that's on the website now. They also have these thumb knobs which allow you to adjust so you can rotate. These are camera angle adjusters that are built in with Teflon. This is a rack and pinion focuser. You'll notice the beautiful fine focus on here that allows you to just make those really fine buttery incremental moves on it. There are also an array of electronic focusers, particularly this one that has a fine focus. It attaches by removing the knob from the pinion. You attach this one. There's also a click lock on here, so you can actually rotate the focuser manually if you wish, which is a really nice feature on here. All ASCOM compliant. The outlets are all inside this little electronic box here. We also have other adapters, such as this for an SET to retrofit a Crayford focuser if you wish to attach one to a Schmidt Cassegrain. This is another example for a Takahashi, an attachment adapter with CAA knobs on it. Beautiful. And we're also proud to announce that Starlight Instruments has taken over Howie Glatter laser collimators. These things are the standard of excellence when it comes to collimating. They're beautifully machined, accurately made. They're collimated right out of the box. You don't have to collimate your own collimator. And if you go online, you'll hear stories about that. You do not have to do that with these things. The QA is amazing on these collimators. This one here has attachments that you can put, if you wish, to put holographic laser tips on it. You can use them to collimate a Ritchie Cretan if you want, or an SET, classical Cascade, Dahl Kirkham, Newtonian reflectors if you wish. Check these things out. These are absolutely beautiful. Visit us at telescopes.net, or you can call us toll free at 888-427-8766 and ask for Dr. D. That is me.
Hey guys, Mike Hatch and Scott Roberts here from Explore Scientific. And we're standing in front of our FPL53 series.
Right. Now, these are three very unique refractors in our line. This is a 115 millimeter f5.5, a 140 f6.5, and a 165. This is our largest refractor at f7. They all come with a 3-inch rack and pinion focuser.
Right.
They have the amazing FPL53 glass, ED glass. This is made by O'Hara. Amazing in itself, but it's also, encased with two other elements, airspace elements that are EMD coated on both surfaces. So, but you don't coat ED glass. A lot of people don't know that. So that's something you don't have to do.
That's interesting.
Its refraction index is such that you don't have to do that. And the refraction index of FPL53 is very high. It has an ABI number of about 95. So
wow.
Fantastic, high contrast, with proper baffling, all the rest of this, an astrophotographer's dream. Now, these have, of course, all carbon fiber. They look beautiful, but what's the advantage?
Oh, right off the bat, super lightweight.
Right.
So being able to handle this, precision optics and, allows you to put it on that mount and be ready to go in the field
without breaking your back.
Without breaking your back.
Right.
Exactly. And the carbon fiber also has other advantages as well.
Okay. Well, one of the big advantages of carbon fiber, you can look on forums and stuff and hear people talk about metal tubes and carbon fiber tubes and all the rest of it, but all metal tubes expand and contract with temperature changes. And these carbon fiber tubes basically have no expansion. So temperature drops or increases, you're not going to have to be refocusing your shot. So that's
nice.
That's a great advantage, especially for those guys who are doing remote imaging, want to just concentrate on their imaging and not have to be fiddling with the focuser throughout the night. So
that's great.
Yeah. Amazing images with these scopes. I was at the Advanced Imaging Conference recently and saw some beautiful stuff done with this ED165. It's just amazing. We have these shots throughout our building, and just to see shots done with our equipment it just makes you feel good. So
oh yeah.
Anyhow, we've got more to show you, so stay tuned.
Thanks.
Hey everyone, Dan Higgins here over at Camera Concepts and Telescope Solutions in Stony Brook, New York. Thank you for joining us for NEAF, the virtual experience in 2020. We know it's been a rough couple of weeks, but we still got the sales for you. So come on down to cameraconcepts.com and take a look at our NEAF sales. But here's the first one, TeleView. We got 15% off on all eyepieces, Barlows, Power Mates, and other accessories at 15% off. So come on down to Camera Concepts and Telescope Solutions. I'll put it down right here. Camera Concepts and Telescope Solutions, 15% off on all eyepieces, Barlows, Power Mates, and other accessories from TeleView. So thank you for joining us for NEAF, the virtual experience in 2020, and we'll see you very soon. Thank you.
Hello everyone, Kevin here from Skywatcher, and welcome to our virtual NEAF experience for 2020. Today we're going to be taking a look at all of our brand new products, and if you want to know more on these products, you can always join us every Friday morning at the Skywatcher USA YouTube channel for our What's Up webcast from 10 a.m. to 11 a.m. Pacific Time. Now without further ado, let's get started and see what's new for Skywatcher this year. The EQ8R series is our new high-capacity mount. It features 110-pound payload capacity, 8-inch diameter gears, and is excellent for telescopes up to 16-inch in diameter or a wide variety of other heavy tubes. This is literally the ultimate imaging mount for the Skywatcher lineup. The EQ8R builds across the original EQ8 and adds new features for the advanced imager. This includes a cable management system featuring 4 USB 3.0 ports, 3 2.1mm power ports, and 3 auxiliary serial cable ports on the back of the mount. This eliminates cable drag and is perfect for remote imaging. It also has onboard homing sensors and a built-in USB to improve connection to the PC without the need of the SynScan controller. To advance the series even more, we have the EQ8RH model. The RH has a built-in Renshaw incremental encoder built in onto the right ascension axis. At 11.8 million ticks, the encoder keeps precise measurements of where the right ascension is currently positioned. This allows for extremely accurate tracking on long focal length and research systems. The EQ8R series can be sold in 2 different configurations, the mount head and the mount head with a tripod. These also include 2 22-pound counterweights. Skywatcher has also updated 2 of our most popular product lines for 2020. The new EQ6R features our brand new updated motor board, which has a built-in USB, which offers direct connection to a PC computer without the need of the SynScan hand controller. Our next update is our FlexTube SynScan Dobsonians now have built-in Wi-Fi. This allows you to control the telescope with your iOS or Android device, and works on our 8, 10, 12, 14, and 16-inch Dobsonians. For 2020, Skywatcher is proud to announce a series of new products to our lineup as well. To begin with those, let's introduce the Solar Quest. The Solar Quest is the ultimate solar mount for those interested in the sun, including eclipse chasers. It has a built-in system called HelioFind, which actually locates and aligns automatically onto the sun. It can do this with built-in GPS and auto-leveling technology. The mount can be powered by 12-volt with an included adapter plate or 8 AA batteries. It features an 11-pound payload capacity, so you can use it with your favorite solar equipment, and includes everything you need to get started, including the mount head, 8-inch pier extension, aluminum tripod, and an accessory tray. The next new addition is our AZ-EQ6. The AZ-EQ6 can be used in Altaz or equatorial configurations, features dual DV saddles as well as a secondary saddle plate that can be attached to the counterweight bar for use of side-by-side telescope setups. The mount features a 44-pound payload capacity per side, which can be extremely effective in dual mode, as well as Freedom Find encoders, which allow you to move the mount around manually without losing your alignment. It also includes a 2-inch rolled steel tripod and 2 11-pound counterweights. Lastly is the new addition for Skywatcher, and that is the Evo Lux ED series. This is a new refractor series that's going to sit between our Evo Stars and our Esprits. The Evo Lux are new, faster ED doublet optics coming in 62 and 82 millimeter apertures to start. These feature a matched doublet with a synthetic fluorite rear element and are fully multi-coated. The mechanics of the Evo Lux series are also upgraded with a retractable dew shield, clamshell with Vixen-style dovetail plate, 2.4-inch dual-speed rack and pinion focusers with a compression ring, and a finder bracket on the clamshell. Well, that's it for our 2020 NEAF virtual experience. If you want to know more about these products, you can check us out at skywatcherusa.com or join us on April 10th on our What's Up webcast on YouTube and see a full in-depth overview of all of our new products. We hope to see you soon, and clear skies.
Hey everybody, Dan Higgins over here at Camera Concepts and Telescope Solutions out in Stony Brook, New York with my co-host Pepper. How you doing? We're here at NEAF, the virtual experience. We got a lot of stuff for you, but let's get down to Explore Scientific. Explore Scientific. We have a lot of deals on telescopes, so let's start off with the 102 and 127 millimeter telescopes. For these telescopes, we got the regular doublet, the Acromats, $100 off. We got the Essential Series, $200 off. We got FCD 100 glass, $400 off. If that's not enough for you, we got 20% off on select mounts, telescopes like the First Light series, and also eyepieces and filters. So come on down to cameraconcepts.com, take a look and see what we got. Here we go, our phone number's on Pepper's side over here. And then you come on down, you take a look and see all the deals we got on Explore Scientific. So thank you so much for joining us for NEAF, the virtual experience, and we'll see you out there very soon. Thank you.
Hello, my name is Robert Reeves. I do a lot of high-resolution lunar imaging with Schmidt-Cassegrains and Newtonian telescopes. The HOTEC Advanced CT collimator and their Newtonian collimator are an absolutely essential part of my imaging system. I cannot achieve the high resolution on the moon that I do without the help of the HOTEC collimators. I highly recommend them to anybody who wants to get the absolute best performance out of their telescope.
I've used a lot of these, and this is by far the best one I've ever used. One of the things I really like about it is how it snugs. By turning this dial here, you actually increase the diameter of the thing here. It really snugs into your focuses, so there's absolutely no slop. Okay. Then we send the beam down off the secondary. This is on my 24-inch Tom Ossipowski slipstream telescope. It's a beautiful instrument. I use it just for viewing, and we send this thing down and get the dots centered on the ring in the primary, and then I can go back down to the primary and look back up here, and right here you can see the beam coming back on itself, and all we have to do is set the tilt of the primary so that the dot comes back on top of itself, and you have literally perfect collimation right there in the daytime. And this thing saves so much time, and it's very accurate. Highly recommended. Probably without a doubt, this is the best one I've ever used. So that's about it.
Hello, I'm Richard from Hercules Telescope. So we are selling a Newtonian telescope like this one, and we have some nice features to have, like to have 4 cameras on the same telescope. But it can be a problem when coming the time to collimate everything. So we are using the OTEC instrument to make it easier with this one and the small laser. So it's almost the only way we find to collimate everything perfectly. So that's why we recommend those instruments to our clients.
Yeah, I've had the pleasure of using the laser collimator, especially in my travels with Newtonian-based telescopes. In my experiences using traditional Cheshire eyepieces and going to the HOTEC laser collimator, I definitely appreciate the quick and very certain way that I'm able to align. I can align very quickly and with certainty without having to interpret what I'm seeing, as is sometimes the case with other types of collimators. The other thing too, with the HOTEC laser collimator in the focuser, it's a very secure connection with the self-centering adapter. So it fits very snug, and it also applies pressure to the inside diameter on all sides, the inside diameter of the focuser, meaning that it will not wiggle or play in the focuser. And as you know, if for others have used lasers, it can have quite a bit of play. So this adapter removes that, and so again it adds to the certainty to the alignment when you're setting up, especially on a fast telescope where you need to be spot on, but you also need to be very clear as to when you're aligned and when you're not aligned. And that's what I've enjoyed most about using the HOTEC laser for that. I know when I'm spot on.
Kevin from Skywatcher USA, checking out the HOTEC laser collimators, and we actually use these at Skywatcher, and I use these personally to align all of our Newtonian optics. So if you're looking for a collimator, definitely recommend getting yourself one of these, especially the crosshair model. So definitely check them out next time you're looking for a collimator.
Hi, I'm Jeff Dickerman with Optic Incorporated, coming to you from beautiful West Michigan, where the weather's still cold, and we haven't seen the stars in a few days, but we're excited to be part of the virtual NEAF 2020 Forum and Conference. State governor's orders, we sent all our staff home to be safe and to be with their families during these troubling times. But we're going to take advantage of this opportunity to show you a little bit of our capabilities here at OpTech and some of the projects we've been working on, and show you what our plant and facilities look like. So please tune in to our OpTech YouTube channel and subscribe below. feel free to leave comments and let us know what you think of our little makeshift studio here. We're going to be doing some how-to videos during this quiet downtime. And remember, we're here for you, and we want to help you out. And we're not going anywhere.
Hey everybody, Scott Roberts, Mike Hatch, both here to talk about our second door prize. We decided to double down for NEAF, the virtual experience, here for the 2020 NEAF. And what I'm holding in my hand is an ED 102 Essential Series Airspace Triplet Telescope.
Airspace Triplet.
Tell me a little bit about it, Mike.
So this is our Airspace Triplet Telescope. It's an F7. So we've got a nice compact refractor here. We've got our extendable and retractable dew shield, so you can store that in nice tight spaces.
Ooh, yeah.
Oh yeah. It does come standard with our 2-speed 2-inch rack and pinion focuser.
Right.
Great for astrophotography.
Right. Now, we got this Canon camera. Is that going to come with it too?
The
or?
Canon camera will not come with it.
No.
But a 2-inch zero power field flattener will.
That's right. That's right. So, there's some other really cool parts about this is that the telescope has our EMD coating. It has a push-pull 3-point collimation system, but there's also centering screws. So if you really want to get into this and just tweak with the collimation as much as you want to, then that's fine. But they do come very nicely collimated. Chances are you'll never have to collimate it again for the rest of your life. If you ever have to, though, Explore Scientific will do maintenance and service of this forever. So we have a transferable lifetime warranty on this telescope. It comes with a Vixen style dovetail mount, but that could come off and you could put a Lost Mandy style, and this is just a great telescope for astrophotography. Oh yeah. It's a great visual instrument, and so this is part of our door prize offering, and this is normal retail prices?
$11.99.
Okay, and the NEAF special is going to be?
$9.99.
$9.99. That's a super deal. So that's awesome. So for just under $1,000, you can have an amazing visual instrument, astrograph, all from Explore Scientific, and there's more to come.
Yeah, thanks.
Did somebody say free shipping? They're doing free shipping at Camera Concepts? Oh my God, they're doing free shipping at Camera Concepts. You guys won't believe it. Anywhere from Washington to Florida, from California to Maine, or anywhere in between in the upper 48, free shipping. The only thing that you have to do when you go to cameraconcepts.com, when you check out, enter the code free ship, and you will get free shipping to the continental United States and the upper 48. So come on down to cameraconcepts.com or give us a call at 631-475-1118 and get your free shipping now. So now you got the best prices, you got the best service from Jeff and the team over at Camera Concepts, and you got free shipping. No excuses now. Come on down to cameraconcepts.com again, or give us a call, 631-475-1118, and we'll be happy to take your order and give you your free shipping and get your order out right away. So thank you for watching NEAF, the virtual experience, and we'll see you soon. Enjoy the rest of your day. Thanks for watching. Enjoy the show.
Hello, my name is Simon. I am the stupid astronomer because I do the stupid things so you don't have to. And I have with me a bunch of QHY goodies on display here. I've actually got one of their cameras and the filter wheel. I'm going to go into some detail about their filter wheel first.
it just looks like a filter wheel. I mean, there's nothing special about it from that perspective because, you know, all filter wheels are created equal, or are they? So one of the things about the QHY filter wheels is they have 3 varying sizes. You've got the mini one, you've got the regular medium-sized one, the one that you're probably used to, and they've got this great big thing. I mean, it's some serious piece of machinery right here. This one can accept anything up to like 2 inches. Generally speaking, they tend to have like 7 positions and things like that. What's more important about it here is the actual way that the actual carousel moves on the inside. They actually have indexing marks inside that ensures that they land in the exact same position each time round. So if you were doing flats and things like that, you kind of want to make sure that this lands back on that particular filter. So when you're doing your flats, you don't get those dust donuts that are slightly out of position and don't match your light frames. So I also have here one of QHY's cameras here. It's one of these little guys. Nothing special here, or is it? So one of the big things that QHY does that is different from a lot of the other companies here is they actually have a interface that is built in that works in conjunction with their filter wheels. It's all USB 2, USB 3 compliant depending on which camera that you have. They all come with every adapter that you could possibly need in order to be able to attach your camera to any particular telescope or even their filter wheels. So as an example, you can just about see inside. These things actually go in. They use a dovetail system, and if you were to use some of their larger cameras, because this is one of the larger filter wheels, this goes in and then you can tighten all of this stuff down to hold onto the camera. The reason why they opted to do the dovetail design is it allows you to orientate the camera into any particular position. And if you have something like their off-axis guider that is mounted here, you can understand how you need to rotate the camera in order to avoid the pick-off mirror. There's also a chamber here for if you actually get any fogging on the inside, you can replace the desiccant tablets just here, and that will just draw out the moisture. There's a whole process. You can read up about it within the instruction manuals. They have cameras, all different sizes, all different shapes. One thing that we like about them is their build quality. When you buy something like a QH camera, you're buying it because of the build quality and you know you get something good. My name is Simon, I am the Stupid Astronomer. If you want any more information about this, feel free to give us a call. The number is 888-427-8766, and I will see you again soon.
Hi everyone, Dan Higgins here from Camera Concepts again, and thank you for joining us for NEAF, the virtual experience. And it's a once in a lifetime thing, I hope, but you know, figuring that it's a once in a lifetime thing, figured I'll start growing a goatee since I'm going to be on lockdown for the next couple of weeks anyway. So let's see how that works out for me, but we'll see. Anyway, let's talk about the deals that we got going on. So we got the first of 2 deals from Mead. The first set is the LX85 series mounts. You could save $300 from across the entire series. So let's talk about the mount first. The mount has a 33-pound payload capacity, comes with the Audio Star, tells you what you're looking at, gives you a little speaker in the back, so it's kind of cool. It's got a integrated ST4 auto guide port and a DC power cable. So that's really good. They're $100 off, now $699. In the series, we also have SCTs, Max, reflectors, and refractors, all on sale. So they're going to be up here on the screen. The first we got the 6-inch Mac. That's $200 off. Originally $13.99, $11.99 now. After that, we have the reflectors. $200 off the 6. That makes it $7.99, and $150 off the 8, which makes it $9.99. Then you got the 5-inch refractor. $200 off the sale price. $200 off. Sale price is going to be $9.99. And then you got the Schmitz. You got the 6 and you got the 8. You got the 6 is $200 off for $11.99, and the 8 is $300 off for a sale price of $14.99. So come on down to cameraconcepts.com. Give us a call maybe at 631-475-1118 and get your LX85 NEAF deals today. And we'll be happy to see you either online or give us a call. So thank you very much for watching and enjoy the rest of the show.
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
As mom.
It's great to be here. Thank you. Wow, there are a lot of
Hello again. Our next speaker is the Chief Executive Officer of the Mount Wilson Observatory and is the grandson of George Ellery Hale. George Ellery Hale was an American solar astronomer and the key figure in the planning and construction of the first modern American observatories. Let's all welcome to NEAF, the virtual experience, Sam Hale.
Good afternoon. My name is Sam Hale, and as some of you may have guessed from my name, I'm related to George Ellery Hale, the founder of the Mount Wilson Observatory. He was my grandfather. But I think I can say, without exaggeration and without boasting, that he was one of the most visionary and influential scientists in history. Yet many people have never heard of him. Even few know something about his many accomplishments. George Ellery Hale is not a household name, and I have a confession to make which may surprise you. George Ellery Hale was not a household name in the home I grew up in either. He died 4 years before I was born, and he was rarely mentioned in my parents' home. As a boy, although I knew he was the founder of the famous Mount Wilson Observatory, the most productive one in history, which completely revolutionized our understanding of the universe. Here is the observatory, more than a mile high in the San Gabriel Mountains above Pasadena. The unfortunate fact is that my parents' relationship with my grandfather, I think, was somewhat different and maybe a bit strained. I don't know the whole story, but it is possible that my grandfather, a super achiever to say the least, could have considered my dad, who was not a scientist, to be an underachiever. We'll never know. There is nobody alive today who knew my grandfather except my oldest brother, and he doesn't remember. For a good part of my adult life, I didn't know much about George Ellery Hale, even though I lived in Pasadena and could clearly see the observatory above the city. Then a little more than 20 years ago, I was invited to join the observatory's board of trustees. I knew I was only asked because I was George Ellery's grandson. Nonetheless, I was intrigued and said yes. I became very interested in finding out who he was and how he achieved so much. Here are the drawings of his great telescopes, 2 of which are on Mount Wilson. I will tell you more about them, but how did he manage to build the biggest telescope in the world 4 times? The first one opened in 1897, and the last one was not superseded until the first Keck telescope was finished in Hawaii in 1993. For nearly a century, during the most important time in the history of astronomy, his telescopes were the biggest and the best. My grandfather grew up in a wealthy family. His father, William, had become very successful in building some of the first high-rises in Chicago and engineering elevators that made vertical cities possible. According to architect Louis Sullivan, William Hale was one of the 2 men responsible for the modern office building. This is Rookery, one of William Hale's buildings in Chicago. Still standing, it is the oldest steel high-rise in the world. My grandfather was born in 1868. As a boy, he was interested in all sorts of scientific subjects and instruments. But his father, instead of just writing a check for whatever new piece of equipment his son desired, had George made a case for it. For example, when my grandfather wanted his first 4-inch telescope at age 14, he had to write a proposal. He explained that he needed to view the 1882 transit of Venus across the face of the sun. He further explained to his father that these events were rare. The next one wouldn't occur until 2004. At an early age, George had developed talent for persuading wealthy people to donate money for scientific purposes by practicing on his father. Shortly after receiving his first telescope, the young teenager became interested in the two research topics that would become the focus of his life's work. The first being solar astronomy. Hale would frequently remind people that if you want to understand the stars, you should spend a lot of time and effort on the sun, as it's the only star we can study up close. During his later years, he would often say, perhaps only half in jest, that he was a sun worshiper. The second was spectroscopy. This was a relatively new area of physics where you could pass light from any source through a prism and spread it out into all its colors. By studying the light at different wavelengths, you could learn a great deal about its source. For instance, here we see a solar spectrum with dark absorption lines that reveal the different elements of the sun. When Hale found out that you could know what the sun was made of by studying its light, he was hooked. Here is Hale as a student at MIT, where he studied physics. He spent his weekends at the Harvard Observatory, which was right down the street. There he developed a new instrument called the spectroheliograph to photograph the sun in a single wavelength, revealing surface details that had never been seen before. He also undoubtedly heard of Mount Wilson for the first time, as Harvard had just set up a small observatory there to test the astronomical seeing conditions. Upon graduating in 1890, he married my grandmother, Evelina Conklin. They took a honeymoon trip to the West, and one of the stops was Lick Observatory near San Jose, California, which had a 36-inch telescope, the largest in the world. My grandfather wrote to a friend saying that it was the highlight of the trip. That tells you something about his priorities. When he arrived back in Chicago, Hale's father gave his son an observatory, which was built in the empty lot next to their mansion, namely the Kenwood Observatory, after which their neighborhood was called. It housed a 12-inch telescope, which any university at the time would be happy to have. Here he worked on his ideas for a new kind of astronomy. For centuries, the primary concern of astronomers was to chart the heavens with ever greater accuracy and to improve timekeeping. But Hale and a few other pioneering astrophysicists wanted to know how stars worked. They wanted to know if they might have life cycles from birth to death, like living organisms. Their new discipline would combine laboratory experiments with telescope observations to really begin to unravel the mysteries of the stars through spectroscopy. 1892 was a really good year for Hale. He and his father negotiated with the new University of Chicago to donate the Kenwood Observatory to the school. And in exchange, Hale would become the head of their new Department of Astronomy. Then at a conference in Buffalo, New York, he heard that the glass for the lens of a giant 40-inch telescope was sitting in the shop of the best telescope maker in America, but with no one to buy it. He rushed back to Chicago and, using his father's business connections, found an individual to build the telescope, Charles Yerkes. Yerkes had gained control over a large area of Chicago's mass transit lines. He had a well-deserved reputation for corruption, bribery, and blackmail. Hale convinced him that if he donated the largest telescope in the world to the University of Chicago, it would improve his public image. The news of the gift did improve his standing, and he ultimately paid for the whole observatory building, which was built 70 miles north of the city in Wisconsin. Hale was only 24. In just 10 years, he had gone from a 4-inch telescope to soon having the biggest one in the world. Here is the giant 40-inch refractor at Yerkes Observatory finished in 1897. It is still the largest refracting telescope ever made, using a large lens to focus the light instead of a mirror. Before it was even finished, Hale knew it was obsolete. Reflecting telescopes using large mirrors to focus the light were the future. They would be much better for spectroscopy and astrophysics, and given the funding, could be made much larger than lenses. George Ellery Hale also had an eagle eye for talent. Over the years, he attracted the very best instrument builders and astronomers to his observatories. In Chicago, he met the man who would make these next telescopes possible, master optician George Willis Ritchie. While he does not look like a fun guy to hang out with, Ritchie, largely self-taught in optics, became the best optician in the world, the ideal OCD perfectionist to spend years grinding and polishing the world's largest telescope mirrors. He was a genius, the Wright brothers of telescope making. Here is Ritchie's 24-inch reflector in a small dome at Yerkes. You can see the mirror at the bottom of the telescope too. Although much smaller than the big refractor, it would produce better photographs. It was the prototype for the two larger reflecting telescopes he would later build at Mount Wilson. This is the last gift that William Hale made to my grandfather before he died. It is a 60-inch piece of glass from France, made by the same company that fabricated the mirror in the Hall of Mirrors at Versailles for Louis XIV. In this photo, we see it as it is today, being lifted